Okay. Hi, Jeff. Can you hear me?
I sure can.
Okay. I'm in, it looks like. I found your email. I haven't not joined yet, though. Do I have to type in the password?
No, you're already in.
Oh, okay.
Yep.
Uh,
I see a lot of us here. Charles, do you have an attendance sheet?
I do. Let me bring it up. Hold on.
Mark, I can get your system. Thank you, sir.
Oh, I say that. Where's my Excel? Okay, I'm gonna have to move it over to the other screen, but I've got it.
All right.
Somebody can't just walk into an office.
Buddy, let's see, Michael Springer. Michael's not on the list.
Well, we just write down names that don't appear.
Oh yeah, there he is, Springer. Yeah, I found him. John Elliott. Okay, let me. Can everybody hear me? I guess.
Yeah, I think so.
Okay. Let me blow up this to the full page. Wow. Bully. Let's see. Dylan Bowie.
Dylan, probably.
He's the first one on the list.
Yeah,
All right.
that's Dylan Bowie.
Okay, Elliot. They must
Here.
not have their mics on. I can see 20 participants. Yeah, everybody must be here. Fleming, Rye.
Yep, I'm here.
Iris, Ice, Goyle. If I mispronounce your name, wave it, hold up your hand and I'll try to fix it. Jones, Zachariah, Kidder, Kidder, Ian.
Hi. Yep, I'm here.
Luna, Roberto, Jonathan Modig,
I'm here.
Gurava Mohile, H-O-H-I-L-E, M-O rather. Lynn Wynn,
I'm here.
Sydney
Here.
Nin,
I'm here.
Rahil Patel,
Yes, I'm here.
Doug Pham, Michael Springer,
I'm here.
I saw him. Davida Thapa,
I'm here.
Ethan Vasquez,
I'm here.
William Vorster. Do we have anybody else?
All right, gang. So what we're going to do for the next 7 hours of our life, or whatever, including the lunch break, is first thing we're going to do is we're just going to dip into a review programming concepts and how they'll plug in into what we will be doing later with testing.
Jeff, it says your audio is very faint.
All right, I wonder what I can do to fix that.
I don't know. I'm
I
not
still
sure where
see
the
your-
mic adjustment is.
I still
I
see
see
your
a mic down in the bottom.
Why? Because they're hearing me through your microphone. All right, now they're hearing me through mine. Much better. All righty, thank y'all guys. So what we're gonna do is we're going to do a quick review of programming structure concepts, and then we're going to work our way through the presentation of the unit testing concepts that we're going to be hitting. Then we're going to do C# demonstrations so that we're all up to speed on C#, or if you've never seen it before, then you will know it. And of course, I mean, you know, not become an expert just over the course of an hour or whatever, and hopefully have time to do a graphical user interface using C# as well. And then we're gonna work on doing unit testing with C#. So do we have Mac users here? Are we gonna have to take that into consideration? All righty, okay. So Mac users can do this just as well as anybody else. You're going to need to install Visual Studio Community, just like everybody else. There is also a Visual Studio Editor. I forget the exact name of it. It may just be Editor. And that's not the one you want. You want Visual Studio Community or something like that. The editor is just a text editor that you can hook programs into, but we want the whole shebang. So hopefully you've already got that. If not,
Jeff, could I interrupt you for a second?
sure can.
I can't hear you on my speakers, but I can hear you from across the hall.
Well, can everybody else hear me?
I hear you.
I think we may have run into this last time, Charles. I'm not sure.
Yeah, the speakers are up, but I'm not. Well, wait, let me turn them on maybe. Now try something.
All right, can you hear me now?
Yes.
All righty, good deal. So after a little bit, we will be opening up a Canvas web page where people can access files and, you know, do look at the assignments of projects that we're going to be working on. It's not published yet, so we will get that going probably as of the first break in a little bit. Need to copy some files over from the last one that we did. So why don't we just jump right in? So even though our language of choice for today is C#, for the first part of it, we're going to do idle just because, Python, just because the syntax is so obvious and easy to see, right? That's one of the things about Python is it pretty much just looks like pseudocode. So starting from the top, right? What are the four structures of programming, the four logical structures? Textbooks will say three, but I consider function calls to be a fourth, right? Well, you have sequential, right? Just sequential statements, one on top of the other. And you can't see a thing that I'm doing because I haven't shared my screen. So how about I do that?
Little green knob. Ah, okay.
All
It's
righty,
going
can y'all
up.
see me?
Yeah, it's still small. We can see all your icons in the background there. That's
All righty, there we go. Okay, good deal, right? And so that's just, you know, your statements, right? Sequential, one on top of the other. If you were drawing a flow chart, you know, you'd start at the top and then you'd be arranging blocks underneath it, right? And then you have selection, decision statements, right? If A plus B equals 3, then do something, right? And of course you can pile on, you know, with either else or else ifs. Python's weird version of that is elif, so I'm not gonna even bother. And then what's next, right? Looping, for loops, while loops, things like that. So while x is greater than 0, print X and remove 1 from X. And more normally, we would want to write something like X minus minus, right? In order to decrement it. But Python, being its own weird little thing, would say minus equals 1. Or equals minus, yeah. So I'm just going to leave it as X equals X minus 1, right? So we have our sequential, our selection and our decision, our looping / repetition. And then the one that we will mostly be concerning ourselves today, our function or method calls, right? A function is just a named block of code. In this language, they're defined with the DEF keyword, right? All this one's going to say is hello, right? Like that. And then we're going to call it.
Python. How different, Jeff, is Python from C#?
Significantly. Python does not follow the C formatting, which is where you use the curly braces and everything has to be in a main. It's kind of its own thing.
Okay. Because this example that I'm going to put up has the curly braces and all.
Right. Exactly. Right. Okay. So name function is not defined. I tried to call something that wasn't written there. Oh, because I called it function 1. That was brilliant. Why don't we correct that and go ahead and run it? Except just like the last time, I'm going to keep accidentally running the wrong menu option. So I just need to use a keyboard. Okay, so we called our function, right? And so what is a function? It's just a named block of call, a named block of code, right? One or more statements that's been given a name so that you can do, you know, a whole bunch of things with a single call. We're going off the bottom of the screen here. Okay. So we're going to turn all of this into a function and just make this our main function, because in the other programming languages like C, C++, C#, Java, you typically have a main method, right? Or a main function. And so everything we put in there in our code is going to be in a main method. And then we're just going to have a call to that function, right? Now, Python, being strange, lets you define your functions inline straight in your code, but typically you like to arrange it so that your functions are, you know, are listed above, you know, where you're going to be calling them. Not strictly true, certainly not necessary in C# or Java. It is true in C++. So here we have, you know, 20, 30 different statements, all being invoked by one call, right? We execute main and it does all of this stuff. Now I happen to have deleted the call to this function, so it's not going to do it, but we will put that back. Nope, that's not it. It was called function 1. Now, as far as testing is concerned, and I'm expecting that to have, you know, been absolutely flat out of a review. Probably nothing new to you in there, but we're going to talk about a couple things that might be new. What if you have something like this? What if you have a function that does something that generates what would otherwise kill the program, a runtime error, right? So we're just going to say that we're dividing, and we're going to say that X is equal to 1 over 0, right?
Yes, that will not work.
And that's absolutely not going to work. So we're going to call function 1 and we're going to call function 2, and we're going to see what happens. And we're pretty sure that we know what's going to happen. In many programming languages, alrighty, I have an indentation problem. This is one of the most annoying things about Python, is when you don't indent properly, throws a fit. but we can get that back. All righty. Excuse me. All righty. Fine. That's why I like curly braces. So anyways, we're going to run our code. And it did everything, but then it crashed. Down at the bottom, we see our error message, right? It displays a trace where it was when it crashed. And again, it's scrolled some stuff off the bottom of the screen. I wish you would resize yourself. All right, and so there's our error, right? Zero division error, division by zero. And this is the callback stack, right? The error occurred on this line, 6, which if we go over here and we enable the viewing of line numbers, right, where is that? We'll forget it. It's going to be at this point right here, line number 6. And then the call stack shows us that that function, that error was in function 2, which was invoked by main, which was invoked by the call to main. But we don't want things like that to be able to crash our program. So typically what you do is you enclose the risky code in an exception handler. And in this particular language, it looks like this. So we have our try statement, and what that means is anything that's indented under the try command is going to be cordoned off as a risky business, right? And then if an error occurs, and only an error occurs, only in this case, is it going to execute this code right here.
Oopsie.
So the very specific one that we need to get, though, is this was our error, right? And that's the only error we want to trap, because any other kind of errors, we don't want being hidden by the fact that we're looking for this specific error. So we're going to come up here and we're going to say, keep running except if you get a zero division error. And if you do, we're going to print our error message out. And we know that we're going to see that, right? Because we're doing a 1 divided by 0. I'm going to comment this out just so that invalid syntax. That's because I forgot my colon. Every time you begin indented code, the line above it had better have a colon. And that's why we're going to be running for the shelter of a language with braces pretty soon. All right, so it did the division, meaning that it jumped into function 2 and started processing. So we scroll up to function 2 and we see that it says print dividing, and then we could add, a second statement, but what we will see is that we will never see that message. And we will never see that message because once the error occurs, it immediately jumps out of this function, just like there was a return statement there, right? And we know what a return statement is. It's just the thing that can resume control, send control back to the code that invoked your function. But if a runtime error occurs, if an exception is generated, it returns immediately. So we're going to see that message come up, but we're not going to see that message come up because this one's going to kick it back out. Execution will continue from the line where it was called, except since we have that error, it's going to jump here. So if we fill this in with a little bit more, print about to call function 2, right? And then we add print back from function 2. We're going to see that, but we're not going to see that because it will have immediately jumped to this for that specific error. Okay, so if we go and fix our error, right, we don't really want to divide by 0. Maybe it was supposed to be 0 divided by 1. Now everything's going to be copacetic. It's all going to be okay. Right? And so it called function 2. It did the division. The division is done. And we're back from function 2. And it did not jump into this error handling code. Make sense? Okay, the other thing that we're going to be taking advantage of is something called an assert. And an assert is a call to the debugger to say, verify that this condition is true. And if it's not, I want you to generate an exception. It's so important for us to find out if this condition is true or not that we want to crash. So we're just going to, and why would you want your program to crash? Well, in a development environment, it's better for an error to expose itself immediately, right? Rather than run silently with the possibility of corrupted data later. So if you identify points in your code where something has to work, but you're suspicious that it might not, then you can throw an assert. So let's do function 3 called. So at the top of our program, as soon as we invoke it, we're going to see that message. And then we're going to do some kind of useful math, right? So our expected result from this math is going to be 10. And the actual result of this math is going to be 2 times 5. And we're going to compare to make sure that they are the same. And so what we're going to do is we're going to assert that our expected is equal to our actual. Go ahead. Let's give it a shot. We're going to call function 3 and everything's going to work correctly, right? Because it turns out that 2 times 5 as our actual result and our expected value of 10, they are the same. So that's a true statement. So everything is okay. We've asserted that it better be true. And in this case it is. So execution is going to continue cleanly. So let's call function 3 and watch what happens. So we fixed the divide by 0 error, so we're not going to see an oopsie message of any kind. That's okay. That's what we want. Now we've moved on to talk about what happens with when our assert runs. And it worked successfully, right? Because 2 times 5 does equal 10. That is true. All right. Now we're going to do a different test inside function 3. So instead of checking to see if 2 plus 5 is equal to 3, we're going to see if 0.1 plus 0.1 plus 0.1, repeated 10 times, or 5, 6, 7, 8, 9, 10, right? If you add those numbers together, I'm not sure that this indentation is going to work. We're going to find out. If you add those numbers together, 10 instances of adding 0.1 should equal 1, right? Should equal 1.0. Well, let's find out if that's the case. And it's not going to be the case.
Say, Jeff, the slash
But
and
that's
pylon.
floating point error. Yep, just like Charles is saying, this is floating point error, and it's because a lot of numbers cannot be represented precisely in binary, which sounds weird, right? You know, it's computers, it's all ones and zeros, it has to be exact. Well, that's not true, because there are plenty of numbers that cannot be expressed precisely in our base 10 either.
Oh,
If you have 1/3, what does that equal to? That is not equal to that. It's not equal to that, right? It's not equal to, you know, cutting and pasting it. It's something that cannot be expressed in a limited number, in a finite number of digits in our counting system. Well, 0.1 is the same. In binary, you cannot express that within a limited number of digits in binary. So when they get added to each other 10 times, they're not going to be the same. Well, enough talk, let's prove it. All righty, that was supposed to be the backslash. That's the line continuation character. In this particular language, if you have a backslash, it means it goes on from this line to the next line.
is that a backslash or a forward slash?
That one's a backslash.
Okay. So the forward
Is proper division, that's correct.
I'm okay.
OU, okay. So anyways, our assertion error caused it to blow up, right? It failed because our expected value did not equal our exact actual value. And just out of curiosity, let's get the difference, just for funsies, right? Man. All right. Why am I not able to grab the margin here? Okay, there we go. All righty. So just for our.
Will it automatically switch to decimal?
Yes, yeah. All right, so here we go. That's just for our curiosity. Let's go ahead and run it. And we will see that it's a very small number, right? It's a 0 dot followed by 15 zeros followed by that. That's the difference between what we wanted to see and what we actually got was this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Very small number, right? But that's floating point error. And so you actually, when you're comparing two numbers that are floating point, you have to take into account more than just the fact that you're checking precisely. You need to check a range. So what we might want to do then is make sure that if we check the absolute value of it, that we check to see if the delta is small enough for our answer to have been expected. Okay, but again, we're back to the point where it crashed. So coding it in such a way where we generate and assert in order to generate a runtime error is a fine way of doing it, but we also want the capacity to capture that in our test framework, right? Because you want your test framework to run in an automated fashion, and so that you can just start your tests and walk away from it. But if the program crashes during the testing, you know, you may be running, you know, 100 tests or 1,000 tests or 10,000 tests, and you don't want anything to interrupt its execution. But it is. So what we're going to do here is we're going to write a function that tests our function 3. So it calls function 3. But we need to put it in our try catch, right? So we're going to stick the word try here, just like we did with the other one. And so we're asking it, go ahead and try running function 3 for me. But it might generate an exception. So we're going to check for an assertion error. And if it happens, we're going to print a message. Right? We're going to print out the error message. Or we could print it out, you know, using string interpolation like that, which we will also be doing inside C#. All right. And then we can return back from test function, right? So we'll just put a, you know, test function 3 return statement. So this is effectively a unit test of this unit, of this function. We're calling the function in a framework that runs it, and if it generates a runtime error, an assertion, because we're going to be littering our code with assertions, then we can capture it, make sure that it does not crash our program. And it did, in fact, okay, do I still have a call to function 3 down here? I probably do, and I'm going to get rid of that because you will see that the commenting character in C# is the same as it is in C and Java. You know, it's the double slashes. So, all right, let's run it once more. Oops, I didn't call my test function. So we're going to call test underscore function 3, which is going to test that function in a controlled fashion, looking for that assert statement's exception to be generated. Right? And it did crash. It didn't print out an error message, but that's okay. But it crashed, but that try except block caught it so that it did not bring our test environment to a halt, right? So we could write a function called test, which would run a series of tests, right? We might have a test function 1, a test function 2, a test function 3, a test function 4, and so on. Now, we really don't have that many tests, so I'm going to just go ahead and, you know, invoke the test function once. So I'm going to call out the call to main, and instead I'm just going to call the test function. That's all we care about right at this point is testing the test function. And so why does it say error equals? Well, we did not provide an explanation of the problem, right? We caught the error, but when we asserted it, we did not pass in, you know, we did not return a string explaining what happened.
So in the curly brackets, that error should have been defined somewhere else.
Yeah. So we're going to say that this is our error, and we are going to return that error. We're going to throw this text string, the difference between the expected and the actual, as part of the exception that we throw. So now when test function catches the error, it will capture this string that was passed and print that out. Or not, because I left a close parentheses there. All right. What happened there? It did not crash, unlike the last time. Did not throw my error. May skip that and wait for.
Probably need to make a copy, just to be sure we need all the signatures.
Ta-dum, ta-dum, ta-dum. Function 3 call. Print. Assertion here. Colon. Return.
Everybody on the left side, on the road side is signed in.
Sorry, just a sec. Checking the syntax of that because I did not quite get what I was hoping to see. And And if I can't find it in 20 more seconds, then we're just going to gloss past that.
Where did you define error? Up in the top.
We were
somewhere?
passing the error out as part of the assert.
Well,
but
I
it did
mean,
not seem to work.
this actually, won't those curly brackets go to wherever error was defined?
At which point?
Down when you say accept assert as error, okay, then you print error equals error.
Right. So we ought to be getting the explanation of our assert there.
Which is up. It says the F difference is different than expected, and then you're putting the delta in.
Correct. And that will get filled in with that variable right there.
That the one that we found from before.
Correct.
I noticed that Pylon uses different codes for different types of instruction, different colors, excuse me.
Yeah. All right, so my syntax is that the error message, and this looks completely alien. I forgot that it looked like this. The error message follows the assert statement like that with a comma. That looks a little bit crazy, but that's okay. So now this ought to generate the exception, and we should get our error message out here, right? So here we go. Function 3 was called, but it crashed because of the assert statement. And the error, the difference between expected and actual, is that. Now, in C# and in C++ and the like, assert statements usually get ignored by the preprocessor if it is not compiled for debug. If it is compiled to run as, production code, then the asserts are not going to be called. But if you compile it for debug mode, then a macro is set and it checks that. So our text was scrolled off the bottom of the page. Thank you so much. All right. And so we saw that the difference between the expected and the actual was that, right? That's what we wanted to see. It's not what we got, but that's okay, right? We were expecting that error and we did find out in fact. So how could we fix that? I don't know. We could round it, right? We could say that the actual was rounded to, I don't know, hundredths place, thousandths place, 10,000th, right? Anyways, like that.
How about we just round it to the nearest unit?
And I actually think that this needs to be a decimal value.
Because the others are decimal.
But that's all right. So anyways, we want like 5 places of precision. And that made it work, right? All right. So why don't we go ahead and stop here, because I want to get out of focusing too much on the Python syntax. For example, that was a little bit weird. That it does not look like you would see in any other language. So Charles, you want to take a break before you begin, or shall we just plunge on into it? I guess we've only been talking for 40 minutes, so we can just keep going if you think.
Not long. So check and see if anybody needs a break.
Where'd my chat window go? I need to keep chat on the screen so that if anybody says anything, I do not ignore it. Nope, nobody's made any comments. Yeah, guys, feel free to cut in by voice or feel free. Okay, so the question is, will we be needing to code along with you? If you want to, right? As I'm typing stuff on the screen in Visual Studio, if you want to play with the concepts, you can type as well. On the other hand, you'll probably find that I type too quickly and I make changes up and down at the bottom of the code, so you may not be able to follow it. The portion where you will be coding yourself is in the 2 projects that we will be giving you. So one project we will be giving you this evening so you can work on it over the evening. And then the second project we are going to do tomorrow together. And if you've worked on the first project but gotten stuck on it, then you ask questions about it tomorrow as well. So I will periodically, if anybody asks, be happy to distribute the code that I've typed on screen. So if you want, and why not, just to demonstrate that we can do this, I'm going to take the code that I've written here and save it as a text file and give it to y'all. Not that I'm expecting anybody to run it, right? But you could if you so chose. So let me go over to chat and send that file to you.
Yes, I don't have any code that I have to write in this.
Right. Okay.
There's
So
code.
the text file got distributed by chat. You get to see everything that I typed in here. Now, I didn't give enough comments for it to be, completely clear, but we're not learning Python anyways. I'll try to make sure that our C# code is adequately commented. Commenting is a tricky thing because too many in the code becomes unreadable, too little and you're not explaining what the code's doing, and that's unprofessional. So, all right, I'm going to stop blathering and I'm going to stop sharing my screen so that we can proceed from there. Oh yeah, that is correct, right? We're going to be putting our code in Canvas. Exactly. Everything that we type here will be uploaded to Canvas. And so I will be publishing our Canvas course in the next 15 minutes or so while we are doing the PowerPoints and stuff. So let me stop sharing my screen.
I have one question, Jeff.
Yes, sir.
Did I share the screen or just put this up?
Yeah, you're going to need to share your own screen.
Okay.
Because I'm not seeing you yet. I mean, I see you, I don't see your desktop.
Okay. All right. Let's see. How do I share the screen? The second screen, actually, because it's on my second screen now. My picture should have gone away.
It should have. Let me come look.
Okay. I'm looking at these little icons down at the bottom, but they don't tell me anything.
All right, bring up the Zoom interface.
Oh, here's a share screen.
Yeah, there you go. Awesome.
Share screen. Host disabled participant screen sharing.
Okay, let me fix that.
Okay.
All righty, how rude. I set it up so that, well, you have to do this by hand, so that multiple people can share their screen. And it'll be important for y'all to be able to share your screens as well. So I need to enable that, especially for tomorrow when y'all are coding and you run into a problem. So I could say, well, line number 57 looks pretty hinky.
Okay.
All right, give that a shot.
All right, let's see what we do here. Come on.
All right, so you just pick whichever screen you want to share.
Oh, it's screen one. Okay. I probably didn't share the screen. Can you see if you can see that?
One of them.
That wiped out my screen that I could see messages on.
Nope, I still see you. Not seeing any.
All right. Well, let me go back. Okay. Now I think I've got it now.
Okay. So you actually have to click which one you want and click share.
Screen one is where it is.
All right, go for that.
Zoom.
Yeah. Bet you're there now.
Okay.
All right, this is frustrating. I'm still seeing your camera. I'm still not seeing your screen.
Well, interesting.
We see it.
Y'all see it? Okay, great, great. I sure would like to be able to see it too, but I'll shut up and let y'all proceed.
I have it here, Jeff.
Yeah, they see your screen. That's what's important. All right, yeah, I'll take this as well. Thank you.
See if you see any errors in that code
Sure.
that's in there too. Okay, this is mostly words and slides. In fact, it's all slides. There's no, there's only a little bit of slide that have some code on it. It's mostly just words, and we're going to talk about things. If you've got your mics on, I can probably hear you if you need to ask a question. because I don't have the bottom of the screen. This is taking the full screen to see who's got a question. All right, unit testing is what we're most interested in, and that's where we're testing the individual units and components of the various software. Now, unit testing can also be done if you've got software that's embedded in something. Years ago, I worked on a project where we put consoles. The 3001, which is our main facility on Tinker that repairs engines, had a level of 14-foot track that distributed all the things around. And so we built the console that controlled the track, controlled the elevators that got up to the track. And it used an Intel, this is the old time 8080, which was new. And it's kind of interesting. So I wrote a section of tests that each one of the functions that the code had to perform was tested. Now, in just software, as Jeff was going over, the unit that he was using is the smallest part. Usually it's just got one input and output. In the case that we were seeing, it was all on the screen, but it verified the code that was correct, and the test it shows once you get all the individual parts together, then you can put them in and run it, and it makes it a lot easier. Usually the developers who's working on the software is doing the unit test, at least the first part of it. It's generally small again, and if you say you wanted to verify a piece of code that was just a loop, and you wanted to know whether or not it was working properly, as we did earlier, that's with the assert statements. That's a unit test essentially. Okay. All right. Now, software testing. We're doing an investigation. Oh, interesting. Came up at the top to show information. Once we get through, we'll notice unit testing is down at the very bottom of this activity. I don't know that here we are right there. And from unit testing then, when we have multiple units, we can move up, we can do integration testing, then we can do systems testing, and lastly, we can do acceptance testing. And all of this, notice, all starts at the bottom. The unit can be just about anything. It can be a line of code. It's more likely several line of codes. It could be a method or a class. Generally, you want things small enough so that you can see how each piece of your code is working together. The practical aspect is when you've got very small tests, the test will run very fast, and you can do thousands of tests in a second. Probably with processors today, you might even be able to do hundreds of thousands, certainly tens of thousands. Any questions there? Okay, here's another little piece that says, here's our code. We run our test behavior, and goes the function. That's somewhat redundant, since we've already talked about it. These tests are generally written by who's developing the code. And it's going to be key that each piece fit together. So when you get to the integration process for your whole code, then you'll run the whole thing. And all these tests that you've already run say that everything that you've done so far works by its own. Okay, we need to check the interfaces also. Questions? All right, we can statically test them. We've got two really, static and dynamic, that we'll get to later. You look at your code just as Jeff was doing, that he said, okay, now I think this is going to work, and then he actually ran it. Okay, he was doing an analysis with himself as opposed to using a tool. We can do code review, we can do a lot of things, software inspection, and we can walk through because if we think it's good, then we get some of our friends and we do kind of like a peer review. And the sooner that code gets into something, the better it is. The most recent example is this 737 Max that has had some problems. I guess it had more than one problem. The one that was most interesting when I was still working in the software area uh, was when the F-22s were deploying to Guam. Uh, they left from Hawaii with a 135 tanker, and when they got to the international date line, they crossed an edge, and that edge shut down the whole systems on the 22. Fortunately, it was not hard to find, and they went back and got it put together. But it's considerably lower cost and a whole lot of problems if we can find the bugs that are in the code before. Okay, it's early in the development cycle, and sometimes in just trying to test it, you can see where your flaws are. You notice Jeff changed his code sometimes, although he was in Python rather. Uh, it works the same for C sharp or C or C++. Uh, and when you have the test group together, uh, they're easy to automate, and you have good unit testing, and the unit itself is meeting what it's supposed to do. All right. Okay, automated test. This execution of the actual test in comparison to the outlet is done with repetitive and necessary tasks, and it performs tests that it would be hard to do manually. If you had to sit and type on your machine all the time, it would be very, very slow. However, you can test interfaces. The first wide approach is the graphical user interface. The testing generates all the keystrokes and mouse clicks and everything that has to happen. And then there's actually application programming interface, where you go from one set of code to another set of code as you move back and forth. Or you may be going to a different, you may have LRUs, line replaceable units, that have their own processors. And this is accepting inputs and sending back outputs, and we'll test the messenger, and what you expect to see and what you're getting is the same. And generally, now on the line over there in 3220, you have a B52 and a B1 line, I know, maybe more now. But anyway, you're actually using some of the real hardware, but also the provider software can be simulated. But before you get to the very end, you're going to be running on the real thing. Okay, unit testing includes virtually static code and data flow, looks at the metrics, it looks at code peer review and the code coverage, and maybe some additional software testing practices. But for static code, you don't execute the program. You just look at it and say what's going to happen. It's kind of like looking through verifying that the flow chart that you're wanting to implement is what the code is doing. Now, when you run a dynamic analysis, the program itself executes, and it will check. You put test versions in there. It's usually in the source code, and it's going to generate, when you finally finish it all up, you're going to get an object code, .exe file. All right, source code is human readable. What we've been looking at with the Python that we were in there was source code. We did not actually see the ones and zeros or the hex if you're printing out in hex, or if you're on an old 16-bit machine from days gone by, you'd probably see some octal. Any questions? Okay, source code, machine code. Machine code's binary. Our ASCII source code is sometimes interpreted like the BASIC language. If you've had BASIC from years ago, it actually interpreted. However, there was also a BASIC compiler, and that actually executed object code, gave you a .exe file, and it was could run just as fast as without having to interpret it. All right. Now, object code is what actually the hardware itself, the processor, the CPU looks at, and it runs through a line of code at a time and goes down. It's all written in machine code. It's executable, and occasionally you might have an intermediate language between the source code and the executable code, because your source code may be useful for several different computers, and each computer would have its own machine code. Okay, so you have an interpreter in the middle. Uh, the last one of the things that I worked on that did this was machine tools. We had a language called apt, automatically programmed tools. You could write the what you wanted the tool to do, and then it went through a post processor that actually converted it to the particular set of hardware you were running on, so that you could, if you had several different machines from different manufacturers, you could actually use the code to generate 2 or 3 different sets of object code, depending on which piece of hardware you were going to run on. Okay, dynamics. This identifies the defects as you run the program. It's during unit testing. Only thing is that some coding errors might not surface. If you have extensive pieces of code, you may not go down every path. You certainly probably wouldn't generate every possible thing that could happen over the lifetime of the system. But code analysis can, if you do good code analysis, you can probably relook at the static code if you're getting weird errors. One of these things is to look at your data flow. It looks at the calculated values at various points, and perhaps the data is not, it's being truncated, or perhaps it does not round properly. You only have so many bits in the actual registers of a machine, and that's all the accuracy that you can get out of it. For floating point, we saw how we could go down to 10 to the minus 16th, but the first set of 15 zeros just is there, and the actual bits are defined down in the very end of it. All right, so you get information from each point in the procedure, gives you some information about what you're doing. Questions? Okay, now what's a metric? All right, it's anything that you know. The metric that most of us are probably interested in and watch on TV all the time is how many additional people tested positive for this virus. That's a metric. You have the same sorts of things for software. You have system processes. You can reproduce. You know, we change things. You can do debug. You can optimize performance. It also works with the schedule and budget, costs. Several different things are all metrics. The peer review that comes along, actually generates a document where the authoring colleagues have evaluated the content and say, yes, we think it's good to this point. We need some more work, perhaps. The amount of code that's in the program itself. How much of it is actually, did we get to run through? Did we test? Have we got the particular unit test run that covered all the code, but when we put it all together, some of them still didn't get called? So you check the functions. You can have statement execution tests. You can count edges that get executed. You can look for branches and your conditions. Everything is a 1 or a 0, a true or false. Did we check all the conditions that we can have in the code? All right. Questions? All right. Now, unit testing, by its very definition, finds problems early. It may even help identify specification problems. If a flowchart is set up where it was sort of ambiguous, one programmer may have written it one way and it actually does not do what was supposed to be done, or the program may be doing the correct thing and the flowchart may be wrong. So the process of writing the test helps the developer get to all the inputs and outputs and possible errors, and it very clearly defines what the unit actually is going to do. It's the desired behavior. In other words, the requirements that it's supposed to meet. The programmer, the developer, has a very, very close, intimate relationship with it. Okay. Also talks about costs right here. If you first find this bug when the code, when you're first starting, it's very easy to fix. But if you find that it's very difficult or perhaps impossible to actually write a good unit test, then that says you probably got some problems and you need to go back, make sure that the functions are defined, structured correctly, and that the objects relate to each other in the correct manner. Okay, we call things test cases. It's a specification of what the input is, okay, what we're supposed to do under execution, and the testing proceeds and the expected results. The assert that Jeff was using says, okay, this is the expected result. If we don't get this, we have a problem. And it exercises, we make sure we've exercised every program path to verify compliance with our actual requirement. Okay, it's very important that we have a good requirement. Now, sometimes you'll find that people that are actually running the programs in the field have a different idea of what should have happened than what the engineers that listen to them. They may have asked somebody who didn't really understand the program very well. So you have to know that you're really doing the desired, that you've produced the software that the people actually need and can use well. And if you've got good formally designed test cases, you've actually got fairly good documentation, and you've got a effective and consistent regression testing when you go to make changes. It seems like requirements are never static. You do different things, and you want to make sure that your test works for all the different versions of the software that's out there. Okay? And cases embody all the characteristics that are critical to the success. They can indicate if you've got the right units. You know, we were talking about floating point, or you could have fixed point. Different sections of the hardware handle different registers depending on which it is. And you can trap negative behaviors. A division by 0. We trapped the division by 0 in what Jeff did this morning. Okay, anything there? Okay. It documents, I think we talked about the critical characteristics of some do not necessarily rely on code to document the product in development. But most of the things we had to put comments in the code that the code did document itself to a degree. And but the testing lives with the documentation. As things go along and change, you change your test, you change how you use it. The unit test gives the basic understanding of what the unit interface is. One programmer could sit down and have written tests, and then 5 years later or 2 years later, a different programmer comes down, sees what happens, and can make changes and know what's going to work. Okay. Unit tests are easiest when your input parameters and output parameters are known, and only perhaps the function inside the mathematics, the code that you execute might change, but ins and outs generally don't change a whole lot. Uh, Database, this talks about a database needs a mock-up of the database, or you might actually have a separate computer that's got the database in it, a big storage system. Uh, Sometimes you'd have to create that, but it might not be as well as the real one. I think about things like Google that goes out and the database it's using, well, all the work that they've probably done to make sure when you type something in, it tries to find the best match for what you want. It may come back and say, well, here's what we think's the best. Okay. Questions on testing? Okay, the smaller the test, the easier it is to make sure that they're correct, and then you can test for the compound behaviors between the units. Okay, and you can continue this. You can combine tests. You can just keep building on it. You notice that we had a few things in the program Jeffrey worked on this morning that he built down, and we didn't. They were still there. The test that he was doing, though, even though there was a hierarchy there, it is not the same as total integration testing. Integration testing, you may have different things than what you did for your several different unit tests. Generally, it's not going to catch every error in the program. A large, complex program, you're just not going to be able to evaluate every execution path. Okay, now if it's a relatively trivial program, don't have to worry too much. If you're working on, say, a processor for an autopilot, you've got certain inputs to it. It could, in small sense, the unit test can probably do most of it, but still, integration errors may occur. System level errors may occur because somebody's missed some requirements. It's key that if you're testing things, you always go back to the requirement and whoever wrote the requirement, what they really wanted. Okay, in embedded systems, and about everything that you all will be working on that I worked on while I was there was an embedded system. We had a processor that was helped fly the autopilot of the A7. We had A7s. We even had some old F-111 stuff. An interference blanker was one of the first pieces of hardware that had a little set of diode matrix in it that actually worked as a code for what would run for what needed to be blanked and for things that didn't. So it's just sometimes you just won't readily run test programs on an actual development environment unless when you get out to the airplane. We've gone out to the B-52 occasionally and ran some code with some weapons preload testing stuff, and it's exciting. It really is. Okay, let's go here. Okay, the challenge for unit test is setting up realistic and useful conditions for the test. Okay, you have to have all your initialization. Okay, what's supposed to be there. You have to run it in, and then you have to know if you're getting the correct outputs. If you don't put, you know, we've all heard the term garbage in and garbage out. Well, that's true for test. Okay, you might exercise the code, but if it's not exercising it in a realistic context, then it diminishes its value and the accuracy of the test. Okay, also it needs to be sustainable. Keep good data, keep good records, and most of you will be working on projects, and I think you'll probably things that are already processes that are implemented and ingrained so that your application evolves into various testing. Okay. Another thing is you get false positives. And if you get false positives, that means there's something out there that someday is going to give you a answer that your machine is not going to like. And I referenced that Max 737 Max problems. I'm not sure really what went wrong. I have not heard anything. It's been very quiet. I don't know if they're even back on, but I know Boeing certainly did not anticipate all the problems they've had. Now then, we've got a couple of things where to actually do some code, and these were first, you may have heard arrange and act and assert. Okay, generally these are the three actions that you're going to look at when you're testing. You keep your objects, you create them, you've got everything set up, and then you act on them. You can divide them or you can add them up. And assert is what's actually expected, and you clearly separate what's being tested in the act phase from the arrange and assert. And there's less chance to intermix with act code. Okay, and reliability is important. Separating your actions and making your test clearly, highlight and you know what's dependencies are required to call your code and how your code's called and what you're trying to test with the assert. And it's possible that you combine some steps and you can reduce the size. The primary goal, though, is to make the test work and make it as readable as possible. All right. Now then, this code, I'm not sure these brackets I put to get all this on one page. I had to kind of condense the spacing a little bit, but the C# defines a act empty string, and it says the arrange part is a variable. The assert part is that it's equal to 0. Now, does that actually do anything? Well, it's better if you go down, you've got set the new string calculator when you've got string calculator down. All right, that's the variable you've arranged it. Okay. Excuse me. And then you have the actual action. We're setting our actual variable equal to the string calculator that we are doing a dot add to, which was this an add empty string. And then we assert that this is supposed to be equal to 0, actually. All right, you can see where we see in the top one we have no action, nothing that we're calculating. I'm not sure what that is.
I need to mute mine. Sorry about that.
Oh,
We're getting feedback from you and me.
Telephone or something. Okay. Does that code, any comments that you need to make about this, Jeffrey?
No, I don't think so, except a couple of the most famous errors, software errors that I recall reading about. One was one of NASA's Mars landers, and sending something to Mars and actually landing it turned out to be a very difficult process, with Russian and American probes only having like a 50% success rate. But one of them was really sad because one of the modules that had been written was expecting units in imperial units, you know, feet and
English units,
stuff like that. And the other module was expecting metric units, right? You know, liters of propellant and meters and the sort. And so once the thing went into its landing mode, essentially it just, you know, turned directly towards Mars, fired its thrusters and slammed into it. And, you know, there goes your $1.2 billion lander or whatever. So it would have been nice if they'd been able to test to make sure that what one unit, what one code module was providing was what the other one expected.
Also, Jeffrey, Airbus, what's the big Airbus? 350 or 360, something
Yeah.
like that. Uses it's at the time, France and England and Germany all were using different methods of defining certain constants in numbers. And that didn't work very well for them.
No, that wouldn't be ideal.
So, okay, I have one more little thing here, and then we're just about through. Um, and this, I notice, avoid multiple asserts. In other words, each unit test should essentially have just one assert. Now then, there are some exceptions, but generally each test, you can have a whole separate little section for each assert that's going to come up. You'll set it up, and then you'll act on it, and then you'll check it. And if one assert fails, subsequent asserts, as we saw using to this morning, it doesn't even get evaluated. Okay, so if you've got separate asserts, you can fix it so that if you fail one thing, it comes out. You get the information, and the next one tests, and it comes out whether it passed or failed. When you've got multiple asserts in a test case, you're not necessarily guaranteed that all of the tests, all of the asserts will be executed. Okay, once an assertion fails in the framework that is, I think, is being used the majority of the time, it's all over. The preceding tests are also just dropped out. They're considered to fail too, because some functionality that's after that could be working well. Okay. Now there are some exceptions. If you assert against an object, the object is usually fixed, and each assert can check different properties of the object. Okay, so you can run different asserts if you've got a single object that you're testing. You may be testing it for being a certain color, certain size, various activities. All right. Now, here's an example where we've got two asserts. They're right down there. We've got add edge cases and throw the argument for exceptions. Then you assert it's a string calculator at dot add null and dot add a, and that may or may not work. We don't know. However, if we define up above inline data null and data a, and then we have our public part, we've got a void add input null or alphabetic, and it's going to throw an argument accession to string input. And then we have the variable string calculator equals the new string calculator, and then the action, we set actual equal to whatever the string calculator dot add is, and we assert afterwards that if we don't get the explosion, then we just have the one assert as opposed to the two asserts of adding null and a. Okay. Any comments, Jeff?
No, that looks very good. And this was definitely recommended that we cover this. So we'll provide a link to Microsoft's website where some of this is discussed. So that'll be in the PowerPoint that you'll be able to download it in Canvas after a little bit.
Okay. Now, there's many different tools that can be used actually. It all will take place, you're actually connect to the context of the program. We're going to use C#, and I don't know, general purpose, it's relatively new, I think. It's a whole lot of paradigm from programming languages. Strong typing, it's scoped well, it's got good declares, it's good functions, it's object oriented, and it follows good disciplines. Okay, the unit testing framework is a key. It simplifies the process because actually they'll work the framework that Microsoft, I think we're using Microsoft's framework. It will cover a variety of languages. And we saw that this morning, we didn't use C#, did we? But later on this afternoon, we'll be in C#. Okay, and you can do without framework support, and you can write client code. If you've got asserts and exception handling right there, and other flow control of the flow, like if you overstep your bounds, then it says, "Oops, we're gone out of range here." You can, but if you've got the framework, then you can add various unit tests. You can keep sticking different asserts in as you go down relatively easily. All right, we've probably covered all this, but the earlier we find problems, the easier and fewer compound errors that will occur. And it's always cheaper. Cost of fixing a problem early outweighs the cost of fixing it later. It's like
dramatically.
It's
Factor
what?
of 10 or 100.
Yeah, you can debug when you're just worried about one or two things. You can debug it pretty. If it's not working, you can look at it. You can go to your source or look at the manual, and you can Google it and see what you've done wrong. And you can also make a relatively quick change, especially to the source code. And other developers can reuse the code. In other words, if you've written some code that does an excellent quick sort, and you want to quick sort something, you just take something that somebody else has already done that you know works well, and stick it in, assuming you're not violating any copyrights or anything. Okay, test cannot uncover every bug though. You should not expect when somebody comes back and says, "Hey, what's this?" You need to find it. It doesn't catch errors. Unit test only is in the unit. Units that are working together, you may not catch all the integration things, even though all the units work right. The setup between the units may be where the error actually is. It could be in the requirements, could be in the way you sourced it out, a lot of things. And there is some potential time, because when you write code lines into your code, you've actually written more lines of code that really needed to be done. But once you get it tested, I assume you could take it out. Processors today have so much more than our 8080. We had 64K that we had to get all our program fit in. So we couldn't have had any set test code once we finished it up. So any questions before I escape this out and we take a break probably? What do you think, Jeff?
No, I think we're well set.
Okay. All right. I'm going to stop the share here and give it back to you. Okay.
All right, gang, if there are any questions, go ahead and throw them in chat, or, break into voice when we get back. Why don't we plan on breaking for about, 5 minutes and getting back, 10:28 or something like that. And we'll begin C#. We will point you to the Canvas section, and hopefully everybody will be able to log into Canvas. So we'll show you a list of of the student IDs and how to access the Canvas section.
Have you got your Zoom group chat up, Jeff?
Yeah.
There's several questions on there.
Where'd my chat go?
There's about 44 messages out there. I'm not sure.
If I could find them, that'd be great. All righty. I wish I'd expand that.
Yeah, there's one at 9:54, 9:50.
Okay, here we go. Yeah. And there are, the question is about X unit, N unit, etc. There are many different test frameworks, and I believe that the PowerPoint I show uses X unit on PC and N unit on the Mac, just because that's what they were defaulting to. However, we can insert the N unit framework as well on Visual Studio. However, I plan on just going ahead and following the examples in the PowerPoint. And the syntaxes that you use to build your tests are slightly different between the two. But fortunately, after we give our demonstration of them and insert the unit tests, and the framework is pretty obvious to follow because you already have a template on your screen. Okay. So let's see. Rye, what did you link to? I'm going to follow that link and take a look. Okay, excellent. Right, comparing XUnit, NUnit, and Visual Studio. I'm just going to put that as a link in our Canvas page. Okay, right. I did not realize that MS Test would be considered slower than the other ones, but right, since it's the default that comes up when you right-click on something and say insert unit tests through the Visual Studio Editor, that's what I went with. It's what I went with in the PowerPoints, I believe. So very good point, Rye.
I don't think it, for our purposes, like with this class and our actual project, the programs are going to be so small that I don't think it'll be significantly slower.
Exactly. I mean, if it takes 2 seconds to launch and run for us, who cares, right? We're only testing, 100 lines of code or whatever, rather than 200,000 lines of code. All right, let's go ahead and break and be back at 10:30. So see you soon.
Okay.
Charles,
Yes, I'm
the
here.
Canvas section was published. Why don't you go and take a look?
Okay.
I'll be in
Let
your office in
me-
just a sec, as soon as I add that link.
Let me take the Zoom meeting. See how I can get to Google here. Oh, where's my login here?
I'll bring up the page about Canvas as soon as we get back, about how you're going to get onto it. I mean, I guess we could discuss it now during the break. Just a second. I really do need to step away for a moment.
Okay, I've gotten to Canvas. Let's see. Oh, see what's down in our. Okay, I see it's published.
All right, once you're in, take a look at it. If you look at Canvas Aerospace 3 logins, then what we will see is a list of their login IDs, and they're going to say reset password and type in their email address. And that's how they get in.
Okay, I had no idea how to get in.
Yeah, so that was a bitter experience learned last time.
Okay, actually, they're going to have to do a forgot password to type a new password in. Da-dum, 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 da-dum. Jeffrey Thompson. Am I muted? PowerPoint. Got a couple of outlooks. PowerPoint. Mail. Computer science. Zoom. TechFam. PowerPoint. Fam. Couple others. Okay, let's see.
All right, gang, here's the point where we're all going to try to access Canvas. And it's possible that more than one person is not going to be able to get in. And what we have to do is we send email to the Canvas administrator, and they usually help us sort it out. Like sometimes there's a typo in the email address that's registered or something like that. But hopefully the majority of us will get into it. If none of us get into it, which is what happened on Tuesday of the first set of seminars we gave, back in June. So anyways, you're going to go to www.rose.edu. Wait. Canvas.rose.edu. It's where you're going to try to go. Am I sharing my screen yet? Not yet. All right.
No,
Here we go.
Jeffrey Thompson, I'm not sure.
All right, so you see Canvas on my screen right here, hopefully. If we go into modules and we click on Canvas Aerospace3 logins, what we will see so you're going to try to access it. What you're going to do is you're going to click the forgot password link using the login ID. So here's the list of login IDs. So it's typically just your first name followed by a dot followed by your last name, right? And then you're going to provide the email address. I believe you provide the email address. No, I think it goes to your registered email address automatically. And so this is the list that was provided to me of the login IDs and the email address that when you choose reset, it will go to. So give that a shot. I don't want to pull up Canvas now and obscure this screen, but if you look at it and you notice an error in your email address, that would be why you're not receiving the reset password message.
let's see, where is my Zoom? Jeff, can you hear me?
Yes, it can.
Tell them that it's going to be a weird, when they reset their password, that little thing that comes to their email is going to it's a few lines down and it says, here's what your new password is.
Okay.
And then you put that new password in and you go to your account and that lets you set whatever password you want to.
All right, so people are getting in. Excellent. First thing you're going to want to do once you get into Canvas, sorry I had the page covered up, I'll bring it back in a minute, is click on modules or assignments and you will see assignment 0. Just like all programming languages tend to use zero-based indexing, so do our assignment numbers. So all you need to do is to submit a comment saying that you logged into Canvas, right? That shows that you're able to get into Canvas. And looks like several of y'all have already done that. Excellent, y'all are ahead of the game. If I slip into student mode here, I can show you what it looks like. I know that OU and Rose students and lots of people are using Canvas, so it's not going to be a real mystery. All right, so yeah, assignment 0, I'm gonna click on. And by the way, this is just pass fail, right? Working on the projects, you're gonna get credit for it. So let's go ahead and I'm gonna click submit assignment and just type in a comment, right? A text entry. Yay, I got in. And then click submit assignment. And so that's enough to prove that you got in. All right, if you are unable to get in, so Drew, are you able to? Because I need to send a message to the administrator. Y'all are fast. We have 15 like out of 25 students already submitted. Good deal.
Let's see.
All right, Drew, I'll send a message to the administrator and I apologize for that problem. If only one of us have problems, I'm going to feel pretty proud, but I would have felt more proud if it had been none of us.
Joe, Elliot, and I'm not sure what that Goel, Goel. Ethan Vasquez. Yeah, okay.
All right, so just to triple check, if you look on my screen, you see your email address there. Is that correct?
Let's see.
Drew, what'll happen is the administrator will probably just set a password for you and I'll text it to you privately so that you won't have to reset it. That's what my guess is.
Jeff, can you hear me?
Yes, I can.
Everybody that's got a folder in there that says /10, those are the ones that have managed to get logged in.
That's correct.
Okay, the rest would just have a dash, have not gotten logged in correct. I have 1, 2, 3. I have 3. I wonder who test student is. Oh. Oh. 16, 17, July. 10:30.
All right. So hopefully that'll get corrected. Don't worry, you don't need to be doing anything Canvas yet. Yes, it's great if you can access the PowerPoints and the PDFs to watch on your own screen, but if you can just look on our screen until that is corrected. And Drew, I'll private message you the password or whatever response I get back from Chuck. All righty. So if you're able to get in, and I apologize for those who are not, you'll see if you go into modules, assignment 0, you'll also see Introduction to .NET Framework, and then you'll see a PDF called C# Intro. So this is the real beef here, the C# Intro with unit tests. I'm just going to blip into Introduction to .NET Framework for a moment, which is just something I downloaded straight from the net, and it looks a little bit out of date anyways. On the other hand, this one I created myself, so I have more confidence that hopefully it's got some really good stuff in it. So Introduction to C# and unit testing. So why C#? Here's a bunch of gobbledygook, but this is pretty important. Much cleaner than C++, more structured than Visual Basic, more powerful than Java. Well, Java developers might disagree or whatever. C# has an interesting history because although this may not be 100% accurate, what I would say is it's Microsoft's version of Java. Because in the 90s, when Java became a big thing, Microsoft implemented, a version of Java into Visual Studio so you could do Java development. But as they always do, they extended the language because just like they did with HTML, they added Microsoft-specific extensions to HTML so that it looked best using Internet Explorer, right? That's kind of gone by the wayside because not everybody is running Windows anymore, are they? But they added extensions to the Java programming language, and Sun Microsystems, who had created Java and who licensed it, said no, you can't do that. And there were lawsuits involved, and so since they could not extend the programming language, they came up with their own. Now maybe that's not a quite 100% accurate. But what you'll see is that the languages try to remain parity. As soon as C# introduces an interesting syntax, Java will do so as well, and vice versa. However, C# plugs into what's called the .NET framework, which really does have a lot of capacity that Java does not by default have access. And it's part of the Common Language Infrastructure, CLI. So what is the Common Language Infrastructure? Here we go. When you write something, and it doesn't matter which language you write it in, as long as it's .NET compatible, it gets compiled into an intermediate mode. It doesn't get compiled to binary. It doesn't get compiled to object mode that you could then install on PC or whatever and run. Instead, it creates an intermediate language file. And I copied this from the net. I give you the source code link, but if we wrote this, public void say hello, zoom in on that, right? And then it's compiled. It just creates a file that's got a series of bytes, right? Arbitrary bytes. And then if you disassemble that, what you see is something that looks incredibly like assembly. If you've ever done assembly programming, you'll look at that and go, okay, yeah, I understand. That's assembly language, and I don't really want to write in it. I would much rather write console.out.writeline, hello world, rather than write that. Now, of course, the gurus, actually can write straight MSIL, rather than, doing this.
Well, hey, Jeff.
Write your code in Visual Basic.net or in C# or any of the others that are compatible, they will all produce MSIL, which runs on the runtime. Yes, sir, Charles?
If depends on the complexity of the assembler. If you say that 8-bit processor, the 8080, it was not too hard to write an assembly on that.
That is what I learned how to write assembly on myself, and you're right. It has a more limited set of opcodes.
True. As opposed to the 360s, which takes up 4 sheets of paper that's little.
All right, so I got a response back, and I know that the answer is already yes, Drew, but is the information correct? Can you verify if there are any spelling errors? You have already checked. Have you checked your spam junk folder? I bet you have. When clicking forget password, he should be putting in the user ID, not the email. I guess that's what I absolutely need to verify that you were doing. If you were typing in the email address, apparently that was a mistake. Okay, I've gotten the email to reset my password, but when I set it, I can't seem to log in. I'm going to give you his email address and hopefully he won't get too mad at me putting you into contact with him directly.
If you try to Control C, it won't work.
Yeah.
By the way, you have to actually Control C that into Word, blow it up so you can read it well, and then hand type it into the change password.
Right. All right, so there we go. So if we go to the introduction to the .NET framework in PDF, I really am not going to spend much time on this part. It's there for you to read. And like I said, I just copied it. So it looks like it was written in 2008 or whatever. So it's probably a little bit out of date. But it's worth eyeballing because I just want to show you a visual of, all right, so why use .NET? But essentially it's just because the development environments all produce code that was not compatible with each other, right? So you were either a Windows 32 API programmer or you programmed, you know, for a different platform, very specific one. And the code was not really cross-compatible, even if you were using the same language, right? If you're using C++, an integer on one platform would not be the same as an integer on another. And the same is even true today. We're in 2020, and yet if you define a variable as being a long in Visual Studio and you compile it, it's still a 4-byte data type. Whereas if you do it on Linux or on Mac with the appropriate compilers,
32 or so.
then you get an 8-byte data type. And so on Windows, you have to call it a long, right, in order to specify. It's just a difference in the specs.
Yeah.
So let's see, tabbing, all righty. So completely unrelated syntaxes. JavaScript has a syntax much like C, while Visual Basic Script is a subset of Visual Basic. Highly confused mishmash of technologies. .NET to the rescue. Pretty pictures. .NET provides integrated environment for internet, desktop, and mobile devices. Well, I don't know about that so much unless it's running on the server side, because nobody uses Windows phones anymore. It's all Android and iOS. So .NET is a framework, a programming methodology, platform independent, cross-platform. You know, you can write it and it'll run on the Mac and it'll run on the Windows just as easily. It's language insensitive because it compiles down to that intermediate form. And I'm looking for a specific slide. I'm getting tired of looking for it. I am probably going to just, yay, pause there.
Passport.
So what is the common language runtime? That is the runtime engine is what actually executes that intermediate language. And Java works the same way. When you run a Java application, you're not running an executable, you're running a Java engine, which takes the intermediate bytecode that the compiler provides and interprets it to run on the machine of choice. And so the same code will run on whatever platform you need as long as the runtime engine has been ported to that. And a lot of y'all have probably played with, you know, running old video games or whatever inside video game emulators. So if you want to run, you know, PS1 software, you know, video games or Nintendo's, Super Nintendo games, Nintendo 64, the old 80s video games in the arcades, right? The binary code for those stays the same. People just take, you know, cartridge dumps or whatever. But the emulator itself is written to run on the Mac platform or on Windows or on, you know, your Android phone or whatever. So that is what's running in the background when we need to execute one of our .NET applications. When we compile our C# code, it's going to boil down into an MSIL file, which is then interpreted by the Common Language Runtime. And if you'd written it in Visual Basic.NET, the process would be the same thing. All right, let's get back to my point.
It's just like any post processor that's going to a specific target machine.
Right. So it is object-oriented from the ground up. You cannot put anything outside of a class. Unlike C++, which is a C programming language that was extended to support object-oriented programming. In C++, you can create global variables and you can create functions that are not part of any particular class. That is not true of C#. And if you've used Java, then you're already familiar with that idea. If you're a C++ programmer, or if you've used Python and scripting languages and whatever, the same is true. If you're allowed to create, you know, global level methods. And that's what you saw when I was doing this. Eventually I started putting everything inside of functions, but I did not define a class to enclose them, right? So all of this stuff is at file scope. That does not exist in the C# language. And so here's a complete C# program, right? When we create a brand new console app, it's going to look like this. And on Windows, there will be a couple of additional using statements, but we can ignore those. Those just bring in libraries of code. We want to bring in the system code so that we can then call a function that will display something on the screen. And if you look, it's not the word print, it's the word system.console.writeLine. And perhaps you see why I did my first demonstration in Python, so I could just type the word print rather than system.console.writeLine. And the rest of this is all boilerplate that is required for the program to have the structure where your code is going to execute. And again, that's why I did it on Python, so that we could, you know, ignore this framework, but we're not going to anymore. We're going to actually do this. So once you get Visual Studio installed, well, I think I'll wait a little bit more. I'm going to keep talking verbally first. So the C# program structure, you have namespaces, and files can share namespaces, or each file can have its own namespace. That's just a way of divvying up code so that even if you have two classes with the same name, you're working on a team and programmer A created a class called file and programmer B created another class called file, then they can be separated in their own namespaces so that somebody using both of them can specify which file class they want to use. And so our type declarations, you can create structs just like you can in C and C++. You can create classes, interfaces. That's a object-oriented, which is going to be beyond the scope, but it provides inheritance of a form and polymorphism, enums, and delegates. And so the members of the classes, you can have your, you know what, I am going to skip this slide because I like looking at code rather than looking at PowerPoint lists. Okay, so what do we see here? You have to have a main method. If there's no, and what is a method? A method is a function that's attached to a class, right? And so it's easy to slip into the habit of just saying, okay, I have a main function, but technically it's a main method, right? And once you start using the word method everywhere, then even when you're doing C++ programming or Python and you're referring to a function, you can slip up and call it a method, as I did several times earlier. You have to have a main method. What this is showing is that it will accept command line arguments. So if you want to launch it from a command prompt, right, you can type in, you know, so dir star dot, you know, PDF, right? This is the command line argument, and it comes in as a string array that you could then parse. On the other hand, when we run our things through Visual Studio, we just press the magic button and it runs. It's not going to be feeding in command line arguments, so we're going to ignore that unless you went to some trouble to actually specify it. Tabbing is not necessary, but it helps read the code. The Visual Studio editor tries to keep your code tabbed for you. For example, if you type in a curly brace, it goes ahead and tabs the next line. I love the use of braces rather than the Python style reliance purely on indentation. So where even if you mess up your indentation by a single space, your Python program won't run. You saw me run into that error.
Say, Jeff,
Yes, sir.
if you have to compress this for some reason, can you put the class right on the same line? Just
Yes, you can. Yes, you can. This syntax, there we go. We could do that, or we could do that, right? If you wanted
Yeah,
to more code
yeah,
on the screen.
like that. Sure.
Right.
Okay.
Or you could even write an entire program in one line of code pretty much.
Oh, well, once you got past 11 inches, you'd be in trouble.
Yeah, right.
On landscape.
So here we see our print statement, and we see that once you declare a variable, you can have it displayed as part of the string by using interpolation, meaning that you put placeholders inside of curly braces and it will fill the value of that variable expression in as it prints out. And it just happens to be an easier way, in my opinion, of generating output. So I tend to do that.
Did you not have to say output?
I had system.console.writeLine.
Oh, okay.
Right. I did not create an output string beforehand, but I could have. I could have done this. PowerPoint is not the ideal code editor. All right. And then once the output string was created, I could have just sent that to the output instead. Right. That would work just as well. And you saw me give an example of that earlier this morning. So integer types. Of course, there are 8 million different types of integers, just because back in the old days when you had your C compilers and, it wrote to 8-bit words and then 16-bit words and then 32-bit words. And finally, IEEE, came in and specified the proper size of an integer as opposed to a floating point value. Now, anyways, you can declare a variable that's just a simple byte, which is 8 bits. You can declare variables that are 16 bits, 2 bytes wide, right? And so an 8-bit value can go, from 0 to 255. Or if you're using signed bytes, yeah, that's what the S means. Then the first bit indicates whether it's a positive number. And so it takes it from -128 to 127. So if that number is larger than that, you move down to the next type. By default, I would just always use an int unless I had a real strong reason to use anything else. It's certainly easy to use an int. Or the long, which is a double wide int, so that it can hold much larger numbers. An int goes to about plus or minus 2 billion, which is, quite often enough.
Yes, well, we had minus 16 on that one.
Right. And so for that, we needed a floating point type, of which there are 2. There are floats, and then there are doubles. And a double is far more precise, right? It supports exponents of up to 15 or 16. Well, no, that's the
It's even bigger than that.
The first value. It supports exponents like up to 370 or whatever. A double is far more accurate. It's astronomically more accurate than a float. I would just always avoid using a float and in general use a double. If I had done that little test that I did where we calculated the delta, where was that?
Up a little bit. There it was down.
Right. That's looking wrong.
There's subtraction in there. Yeah, right here.
Right.
Delta,
If we had done this using floats, 4-byte values rather than 8-byte values, and Python does its own thing. It doesn't use just 4-byte values and 8-byte values. The delta would have been, the error would have been much larger, right? It would have only had like 7, 0.0007. And so this is a far more accurate data type if you use doubles. And it's the default data type for floating point literals in the language. If you just type in a number, 3.4, it makes it a double automatically. So that's, just ignore the fact that it even offers a float. Remove that from your vocabulary because doubles are the defaults and they're far more precise. So you have your character types, right? You can store a single character. It's not an 8-bit character, unlike C and C++ by default, it's a Unicode character. So it's not simple ASCII. However, ASCII was grandfathered into the Unicode subset. It's about time to actually launch Visual Studio so that I'm typing some stuff rather than just showing PowerPoints.
oh, hey, Jeff.
Yes,
There
sir.
was one on further down character where you actually define decimal characters in it. Go up a little bit. I think slide before. Yes, exact numeric types.
Right. If you're going to do
Yeah.
money calculations, you don't want floating point errors in your money calculations. And that's been part of, movie plots in the movies, Superman 4 and in the 80s, and Office Space, where programmers write programs that siphon off the small minute rounding numbers from currencies and earn billions of dollars in a day or whatever. Well, so anyways, programming languages typically offer an exact numeric type where the rounding error doesn't occur, right? So if we had done the same test that I wrote in Python, but I specified that it was a decimal rather than a float or a double, then we would have gotten a delta of a 0. So that's a very good point. That's just like a BCD, a binary coded decimal, if you've used a language that supported that. All right, so I launched Visual Studio. I'm going to create a new project. And again, this is spelled out later in the PowerPoint. I'm just in a hurry to get to it. Did you crash on me? Nah, it's just being slow.
It's got some old stuff in there.
Yeah, it's amazing how computers increase in power, geometrically every 5 years or whatever, but the software always grows, so that using Visual Studio in 2020 is just as slow as it was for Windows, Windows 95. Come on. Hopefully it's not this slow for you. I don't know what's going on here.
I'm just watching yours.
I should be patient. Oh, come on.
Try running it on an 8080.
Oh, here it comes, here it comes. Yeah, all right. So project name, in unit test project 1. Gonna go ahead and create that. But it did not show me the choices I had made, which is I want a C# application, and you're gonna have slightly different choices available to you on the Mac. And unfortunately, I did not bring my Mac today, so I can't screen share from it. The instructions are in the PowerPoint, and I will bring it tomorrow. And if you need help on the Mac tonight, I will give you my text number, and we can hook up and screen share with each other to get into it. But it's not mandatory that you complete an assignment tonight. It's just would be a good idea. So I'm going to choose C#, and that's true for the Windows users as well. Windows desktop, and what do I want? I want, ooh, there's 2 different versions. Let me go down to where I'm actually demonstrating. Yeah, so the next slides walk us through creating a C# program. That is slide 63. Look for those specific steps for that language. So what I'm going to do is I'm going to create a console app .NET Framework rather than .NET Core. .NET Core is cross-compatible, looks like the one we want, but .NET Framework is the one that wound up working seamlessly with the default unit test framework. So I'm just going to go ahead and choose that on Windows. Different choice on Mac. You can tell which ones you need to be doing by the symbol that I put up in the corner. So going back to Visual Studio, I want a C# Windows console app. So I'm going to pull console here and choose .NET Framework. Give it a name. Aerospace Demo 1.
Aerospace3 Demo 1.
Yeah, that's a good idea. I have found that having Google Drive running in the background eats up an amazing amount of processing cycles when it decides to go and update. So I killed it. So I don't know why my machine is running so slowly. So anyways, here's the framework. I don't need this stuff for the purposes of the demonstrations I'm going to be doing. And when you create it on the Mac, it doesn't even default to adding those libraries. I'm going to remove that. And then I'm going to do the classic hello world, except I'm going to make it print something else, right? Console dot out dot right. Now that's a lot of typing. Microsoft provides code snippets, which are abbreviations. So if I just type in CW tab, it fills it out with console.writeLine. And my mistake was inserting the word out. It would not have compiled. That's a Java thing. I was looking at Java code last night. My mistake. So CW tab expands out to console writeLine. Like that.
Howdy. You're down in Texas, right?
Yep, that's right. That's right. Okay. So let's declare a variable and print that one out. Every line must be terminated by the semicolon punctuation unless there's a curly brace on the line before it. There's two common brace placement styles. Some people like to do that. And the benefit to that is that if you put a semicolon there, it becomes immediately obvious that that's a mistake, right? In some cases, like an if and a loop, it would not even be underlining this stuff with red to show that it's a syntax error. But pretty much anytime you have an opening brace on the line before it, you better not have a semicolon. Every other line is going to have a semicolon. I prefer that block placement of braces, and that's the default for Visual Studio. You can probably change that in the settings. All right, and so now I'm going to print out the value of 3. So I'm going to type in CW tab and say x equals curly brace x for string interpolation, but to get that to work, I'm going to put a $sign there. You saw me use F on Python. C# uses $sign instead. I like $sign. Okay. And if you need to put in escape codes for blank lines, you can do so.
Will it round it to 2 decimals?
Right. This is an integer, so it's going to be a whole number only. It would be a compilation error if I wrote it like that, which is nice because in C++, C++ would compile that just fine and dandy. But of course, it's really only storing 3 in there. So it's nice that we get it as a compilation error. C# is really a dramatically improved, in my opinion, over C++. However, there are things that C++ can do, and C++ is much faster because it compiles down to the native, object code, an executable rather than an intermediate interpreted form, which would be why your PlayStation games and etc. are probably written in C++. Let's go ahead and try this now. So what did I do? There was a green message up here that said run debug or debug program. Now that I've clicked it, I can't see it. Anyways, and so it launches it, and we see that it launched our executable in a test console, and it closed it immediately, did it not? Yes, it closed my app immediately, and that's annoying, right?
Boy.
It runs it and it closes it. Now you can avoid that by choosing debug start without debugging, but I don't know why they made that decision, right? Where if you run it without debugging, it leaves the window open. If you run it with debugging, it closes it. And I'm sure that there's a configuration change I can make to the project to change that behavior. But in lieu of figuring out how to do that, I'm just going to put a console.write line done, press enter message, and then do console.read line, right? So that way it just hangs waiting for me to press enter, right? So at least I get to see my output now in debug mode. And what's the difference? Well, one of the differences is that if you set a breakpoint, setting a breakpoint is when you're trying to figure out what's wrong with your program. I want execution of my program to stop here so that I can find out what what X is before it gets to the next line. So let's put a breakpoint there and let's debug it. It stops at that point. And so if I click on the line that says step over, the icon that says step over, I know it's tiny, but you can see the little pop-up that says step over F10. It executes that line and only that line. And then I can come over here and cover my mouse over the X, and I see that X is currently 3. Or if I have this window open, I can see that there's only currently one variable, which is the variable X, and it has a value of 3. And so I can step through it line by line like that. But you cannot if you run it without debugging, right? If I had
Does F3, hey Jeff, does F3 work as well as using the mouse?
Yes, yeah. I believe F10 will launch it, and F5 will launch it, and F10 is a line by line step over. So I'm going to stop the running of it. If I had compiled it for release, I probably would not be able to run the debugger. If I ran it start without debugging, then I would not stop at that breakpoint. All right, so we see that data type. You can hold a number from like -2 billion to +2 billion with an int. So if we needed a big one, we'd use a log, right? And this can hold a much larger number, like let's go up to 1 trillion, which would be 12 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, I don't remember if this is one of the languages where you can use underscores to break things up every 3 spaces, like we use commas when we're writing numbers down in English. That may just be a Java thing. It seemed to have compiled it. I need to get rid of that breakpoint because it's going to stop there every single time. And so anyways, run it, and there we go, right? And so if I wanted to print out X and I wanted to print out Y, I could say that X comma Y is equal to curly brace X comma curly brace Y, like that. Now the Solution Explorer shows you the structure of the project. There are no header files in this language. Thank goodness for that. If you've done C++ development and you are familiar with the idea of sticking your class prototypes in a header file and then your class bodies in the CPP files, so you have 2 files for every class, that is incredibly annoying if you're used to writing Java or C# code where the class definition is all in one file and there's no header file. So anyways, and so we can see over here in Solution Explorer, if you lose this window, if it disappears, you can always find it under View, Solution Explorer. And we see that I have a CS file, a C# file, and right now I only have one method, right? I have one class and one method inside that class. If I added more methods, like static void test, and all it did is print the word test,
Say, Jeff, how does the word void work in there?
what void means is it does not return anything.
Okay.
You could write another function that returned like an integer.
Okay.
Like that. And so whatever data is being returned from the function has to match the declared data type for the function. And so if we tried to return a value from a void, it's going to tell us, no, you can't even do that. That's a compilation error, right? Because void means don't return anything at all. Whereas if you give it a non-void data type, it's a fruitful function that can actually accept, that will return a
It
value.
will return.
Right. Now the keyword return is optional if it's a void, right? Because you know that it's returning nothing and that is its only choice, but it looks nice to see it. All right, and so now I see that I have 3 methods inside my program class. I'm not going to bother calling those methods. We know it works. Well, I guess I could, right? Let's call the test method. And then let's invoke this F2 method. So I'm going to say X is equal to F2, right? We're going to get the value 10 out of it. So when it runs, it's going to say that X is 10 and Y is equal to 3 trillion. And that is indeed the case. All right, if you want to play with what we have so far, let me save that. We're not done. It's not lunchtime or anything, but I do want to save this so that I can send it out in chat. If anybody wants to pull it up, even in a text editor, you'll be able to do that. So is the error because I haven't declared bill total? Aha. Is that referring to a slide that referenced that? Yes, that would flat out be a mistake. Looking at this slide, and that's very good. We need to update the slide. It's my mistake. Not sure why I did that. This variable should have been called what? It should have been called bill total. So I'm going to do that. And if it's money, I should not have declared it as a double. I should have declared it as a decimal, which is a precise data type that does not exhibit floating point rounding errors. Sorry about my voice, gang. It's giving out early and there's no reason for that.
Is like 98.6, what if that was a temperature in Fahrenheit?
Yeah, you're right. That looks like a temperature. Yeah, it looks like a temperature. I don't know why I chose that number for bill total.
Thinking about the virus, right?
Right. So maybe we got, a $2,000 bill. Where was I? Oh, I was just about to send a file out. All right, if you want to play with what I've typed in so far, you can do so with that. All right, so character types. A string in this language is actually a class, which means it has methods attached to it, meaning that if I type in, if I want to see the methods that are attached to an object, I can just type in that object and hit dot, and it will list everything. If it's capitalized in this language, they follow their own very specific, there's a word that I'm looking for and I'm not following it, their own specific guidelines, is that if it's a capital letter, it's a property rather than being a method, rather than being a function. So if I want the length of that string, and I can get it, right? And z is equal to s dot length. Java, the length function is a method, and so you'd have to put parentheses after it. Let's see what else there is. S dot, and we can see that we could clone the string, we could copy it to another one. I'm not sure what the difference between cloning and copying is. You could check to see if it ends in something. Does this string end in an O? So if s dot ends with parentheses, quote, double quote for string, single quote for characters, it would probably accept a single quote there as well. Yeah. Do you end in an O? Nah, it really wanted a string.
Didn't like
right.
that.
Didn't like that one. That one looks like an emoji, right? Looks like an emoticon. Is a scared face. Better fix him. There we go. Still looks like that. All right. Since there's only one line of code, we can get rid of the braces. But it's not like Python where I can turn around and then add a second line to that indented block. If there's going to be more than one line of code in the block, the braces are mandatory, not optional.
So if you wanted to run a loop, check for every letter of the alphabet, it'd tell you what it ended with.
That's correct. And there's a method that will not only check for the last one, right? If s dot contains, does it contain an E? Does it contain an X? No, it does not. Let me just copy that and paste for speed. So yes, contains an X. Tell you what, why don't we do this? Bool
That's a Boolean.
X found is equal to S contains X. Now, a Boolean variable is a variable that only has two possible values, true and false. If you've done C programming way back in the past, you probably just use an integer or a byte that you set to 0 or 1 for true or false. But more recent languages have a Boolean data type so that you can express a true or a false in those terms. And so what we're doing is we're storing the result of this call into the Boolean variable so that we could then, print it out. Let's print out whether it's true or false. X found, question mark, curly brace, X underscore found, in curly brace, end quote, in parentheses, semicolon. I'm going to get rid of the toolbox over here so I can expand the code, make it a little bit easier to read. All right, so when we run it, is there an X in it? No, of course not. It's equal to hello. So when we print it out, we're going to see the word false there. Or not.
Then press enter.
Oh yeah, I love making that mistake. Look where my done press enter code is. Why don't we stick that at the bottom? And furthermore, why don't we just stick a whole bunch of returns there so I won't make that mistake again. All righty. So hello does end in an O, but no X was found, right? We searched the string and it did not contain an X. You can also ask for the index where that O is or where that X is, right? And it'll tell you that it occurred, it's index position 3 in the string or whatever. Naming convention, thank you, Michael. Thank you very much. I don't know why the word convention slipped my mind. I use it all the time and then as soon as you need it. Okay, so we've been demonstrating interpolated strings, but there's another thing called a verbatim string. And what's a verbatim string? Well, you're probably used to the idea of using \n as your new line, right? 1 \n 2, right? And so it's going to print these things out on separate lines. I swear I thought it flagged it with the red underline as an error, but then when I run it, okay, so line 1 and line 2, right? Maybe I'll stick some \n's, in my done message. Well, that could be a problem though, right? What if we have a file name, string file name equals quote /temp/new file.txt. You may see the problem, right? It's even colorizing the text to show me, to warn me that that is an escape code, right? \n go to new line. And furthermore, \t means tab. So if I print it out, the file name.
What's the $sign do?
$ means interpolated string, meaning it can support embedding expressions inside the string. If I did not have that $ there, then when I print it out, let me show you the result. File name equals curly brace file name. I add the $ and run it. And it takes, well, it no longer says file name equals curly brace file name, right? It says file name is equal to, and it inserted the value of this string there.
EMP.
Right, it replaced it, exactly. Okay, but it sure did look lousy, right? Because it put a tab there and it put a / in there. There's one easy fix. Windows and DOS are the only operating systems I know that use backslashes as a directory character. Everything else uses /. And Windows, being, they made it a long time ago, work with that as well. That's one fix. So now to print it out correctly, because / escape sequences are backslashes, that avoids that problem. Another way is you could do this. You could put double slashes. You may be used to seeing that. And what that means is that this is an escape sequence that is replaced with a single slash. And that's not what we want. Really, that looks lousy. A user is not going to type that, but if they're Windows users, they will type that. And so we're going to put an @ here. And the @ means, oh, this is a verbatim string. Do not do any character substitution. Do not do any, token substitution, and do not support escape sequences. So now it's going to print out our file name using the Windows convention of the backslashes, and it's going to look good. We're not going to see
Changing the character of file name, did you change the color of file name for some reason?
You notice that it did it all by itself. It is doing syntax highlighting. The editor colors different things. The keywords are colored blue. Variables are colored kind of that cyan.
Like it's found up there. Yeah.
Right. And so you can change that if you want by going to Tools. No, it's funny. It has both a customize and an option. So anyways, options, and then we can find, fonts and colors, and we can pick that we wanted comments to be displayed in red rather than green or whatever.
It's got a default.
Right. So let's say that I really hate the current color comments. Wow. Lots of different places. Yeah, I don't want comments to be green. I want them to be magenta. Now that's horrible, right? But you can do that.
Well, that is bright.
Yeah. Maybe I want them that shade. That's going to wind up driving me crazy after a while. Oh, and I haven't been commenting my code anyways, right? But anyways, so that's a 64-bit data type. That's a 32-bit data type. Why don't I change it back to being green? Because that's annoying. And I clicked on customize with options again. All right.
Comments. There you go. Custom.
All right. I think I'll be happy with that. So use @ for verbatim, non-escaped strings. Use $ for interpolated strings with embedded expressions in placeholder braces. You can get kind of weird with that. What was our function called? F2?
Three times. Okay.
Right. So there we go. It's going to call F2, return the result which returns the result of whatever it was, 10 or whatever, and it's going to multiply it by 3, and it's going to add 10 to it. So I expect that it's going to be 40.
You don't
or
actually
whatever.
do an action here. An asynchronous.
Yeah, it's actually going to perform that entire string of commands there. Now, that's getting to the point where it's almost unreadable. So what I would have done is normally I would take that and say, you know, int result is equal to, and then just print out the result, right? That would have been more kind for the next programmer to come along and see. But it's interesting that you can put whatever expression you want in there. Like that. Now these two things perform the same task. So we have a Boolean type, its own thing. It's not interchangeable with int, unlike C++, for example. But you know, behind the scenes, they're still treating a false as a 0 and a true as a 1. Yeah, they got to be doing it like that. But all right, so it supports arrays. The language supports arrays. Unlike Python, if you're a Python programmer, then these are honest to goodness arrays, meaning that they are fixed in length. If you need a dynamic data type, you use a list. And the reason I mention that is because Python only supports lists, and you simulate arrays by using lists in that particular language. Most languages actually support an array type. So you create an array. That does not look right. Wonder where that went. All right, so here's a single dimension. Okay, yeah, whenever you code in, well, that wouldn't work because it's 4, right? All right, so this is saying I want an array of integers, a sequence of integers, and I want it to have room for 4. And I'm going to initialize it with those 4 values. And let's copy and paste that and make sure that it works. So if you're going to provide an initializer list, all right, what you complaining about? Bad declarator. Forgot. C# follows a Java convention. I told you it's a clone of Java. It's not strictly true, of putting the braces over there rather than after the variable name as you do in C and C++. So we've created an array that can hold 4 numbers there. And I believe that you can put a size declarator there as well, but unlike C++, okay, no. In C++, you're allowed to put both a size declarator and an initialization list. And if this is larger than the length of the initialization list, it pads it out with zeros. Not true. If you're going to give it an initializing, so like that, you just do that, right? So that's a single dimensional array. Or maybe we want, you know, I'm not sure why I capitalized that. Probably Python, probably PowerPoint wanted me to do that. And so we're going to make another array, you know, an integer array is equal to a new integer array of length 4, right? But that's all initialized to 0. Every element is a 0 if you do it in that case. And it does go ahead and initialize it, unlike C++, which just leaves whatever garbage was in, you know, in those bytes. They're still there until you initialize them yourself. So those are 2 examples of array declarations. Let's correct the PowerPoint. I will upload that during the lunch break with the correction. So here we've declared a variable, an array, and then since they are fixed in length, if we needed to add more than 4 numbers to it, we would actually have to reallocate the array. So typically what you wind up doing is if you need to extend an array, you allocate a new array and you copy the old values into it. right? Here's an example of a two-dimensional array declaration. You put a comma in there. Let's go ahead and do that. And a two-dimensional array is just a matrix, right? Like a spreadsheet where you have both rows and columns. So if I pad it out, that syntax looks nasty, doesn't it? I can probably get rid of that and just say this, and it's a two-dimensional array. I'm going to use excessive tabbing here. Excessive white space. There. You can see what's going on. It's got 2 rows of 3 columns. What if I just wanted it to be the same thing but blank? 2dim equals new int of 2 comma 3, right? 2 rows, 3 columns. There's also a syntax, which you've probably seen in other languages, where if you have an array, oh, come on. Array name, and then you put in, you know, a row specifier and a column specifier in 2 different pairs of square braces. That creates, or that is accessing a jagged array, which is actually an entirely different thing than a two-dimensional array, because every row might have a different number of columns if you're doing that. And so it's a strange idea. But let's go ahead and look at the slide. So to correct that, what did we need to do? We needed to have the array type. And we did not need that. But then we could do that on the next line, right? 2dim equals new int, you know, and we're going to make a 2x3 array. And then here's our jagged array. Create an array where we have 1 row, and then you allocate each row separately. Bizarre idea, right? If I needed 2 rows in my jagged array, because if it was 1, you know, a 1 by whatever array, then you just use a single dimensional array. But anyways, in that case, you could declare it as being 2, and then you would allocate row 0 and row 1 separately. Rarely use jagged arrays, because rectangular arrays where every row has the same number of elements is, you know, a much more common idea. That's the syntax that you've seen, though, where you use the 2 sets of braces rather than the 1 brace with a comma as your delimiter. So these are simple data types. Other languages may call them primitives. This says that they directly contain their data. What is odd about that statement is that I know that absolutely everything in this language is really an object. How do I know that? If I type in my variable dot, it goes ahead and lists a whole bunch of properties and methods, right? You want to convert that to a string, right? String my string is equal to my variable dot toString. You can do that, right? Why are you underlined? Okay, it fixed itself. So this variable, even though it looks like it's a primitive data type, has methods and properties attached to it. Just kind of weird. And that is not true for your Java programmers. And it's not true for your C++ programmers, where ints and floats and doubles and longs are primitive data types. They're not objects. So that's telling us that int is actually a class, right? It's an abstract data type. So we have ints and longs and bools and chars and floats and strings. So statements and comments, we've noticed this. Almost everything ends in a semicolon. It's definitely case sensitive. The block delimiter are our curly braces. Single line comments are double slashes, and block comments are slash star star slash.
This is a long comment.
Now it's trying to be helpful, and when I started a multi-line comment, it put an asterisk on each successive line. But of course, you don't have to do that. But it is kind of pretty, isn't it? Right. So just makes it leap out, and it does that for you. If you're curious about what code snippets, what abbreviations, and I never remember more than CW, but you can go to Google and look up Visual Studio Code or C# code snippets. And they call it the code snippet inserter. CW is a call to write line. I wish they had one for read line. If you type do and then hit tab, it creates the whole syntax for it. If is probably the same. If tab creates that kind of structure. I used one for OS2 where if you typed if, it would go ahead and fill in that, and even put an else down there, which was incredibly aggravating because you most of the time you wound up deleting that. Anyways, and then there's do, tab creates the skeleton for a do loop. While tab creates the skeleton for a while loop. For tab creates the skeleton for a for loop, and so on. Now I'm going to delete these, just showing you the code snippets that you have available to you. Make your typing a little bit faster.
It didn't like your little squiggle there.
Yeah. So data, all data types derive from system object. It's an object-oriented language. There's an object class that everything inherits from. If we just create a generic object, and we type O dot, we will see that every object is guaranteed to have a toString, a get type, a get hash code, and an equals method, right? So anything is guaranteed to have those interface methods, like, a string. I've already done that, or an int or a double, double D is equal to, I think I already used that. Double D value is equal to 1.2 e to the 34, so on. Doubles are floating point types, so they do support floating point notation. And then if I type in D value dot, we will see that it still has those methods, toString and get hash code. Seems like there were more there when I typed in O dot. Get type and equals, I'm surprised. Okay, there's a get type. I know that there's a D value dot get type. Yeah, anyways. So for example, everything inherits from the root object class. So everything is an object, even primitive value types like int and char. So that's why you can do dvalue.toString and things like that. It was talking about hash codes. Let's print out the hash for whatever a D value is, right? I can't tell you what method it is using to generate that. That's a method, not a property, so I need his parentheses afterwards. That looks really lame. I don't know why I did it like that. No, I guess it did it. All right. Anyways, there we go, right? Just out of curiosity, let's run it and see. All righty. A curly brace character must be escaped in an interpolated string. In all those edits, I lost my opening curly brace. There we go. Okay, so there's the hash of that D value. And if I created a second double, right? D value 1, comma, D value 2 is equal to the same thing. Let's print out the hash for both of them. Hashes are used for like dictionary structures where, you know, it needs to be able to differentiate one value from another in order to insert it into a structure. So let's compare D value 1 and D value 2. See, they're the same value, hashed, but if I changed one of them, like it's equal to 3.14159, right? Then the values are going to be different. That's just for funsies. Now let's go and continue. C# does not automatically initialize local variables, but at least it warns you. In C++, there's a distinction between global variables, which are automatically initialized to 0, and local variables, which are not, but this language does not have global variables. You can kind of simulate them by making static variables, but at least then they are part of a class. We will talk about what a static variable and static method is. So if you need to figure out how many items are in an array, you can use the .length property. So let's create an array called colors. And our colors are red, green, and blue, right? And now we're going to print that out using a for loop. For int index is equal to 0, semicolon. Keep running while our index is less than colors.length, semicolon. Index plus plus. Normally I would just use I. And then let's CW colors at that subscript, right? That's one way of doing it. Even if I shortened index, editors are nice because you can right click on it and choose rename, and it'll rename all occurrences of it in that loop. So I'm going to rename index to just the letter I, apply it, and now it's made it a little bit more readable. But there is another type of loop called for each. For each string value in the colors array, and I'm sorry, there's no space between that. I'm going to get rid of the braces here because, like I said, if your block of code only is one long, then you're allowed to get rid of it. Print out V. So if you have a list, if you have an array, if you have any kind of structure that supports iterating through it, you can use a for each loop. And you've seen variants of that syntax in C++ and in Java and Python. If you are not familiar with this syntax of for loop, hopefully it's pretty intuitive. That's your initialization step. That's the comparison, the condition that allows it to continue. And that's the update that occurs after the body of the loop has been executed. Does C# support matrix operations, or do you need an external library? You certainly do not need to write it yourself. And 3 rows and 2 columns, is that the case? If I said the opposite and I did 2, 3, yeah, you're correct. So if I said the opposite, I was wrong at that point. Thank you. So matrix operations, you do not need to write your own. C# matrix library. Stack Overflow knows everything. Math.net.numerics. The older math.net Iridium supports more options. And then you can download some external libraries to support it. So yes, there are ways of doing it. I actually have not looked at matrix under C#, but absolutely you can. I love it. People are so snarky on Stack Overflow. This question is not a good fit for our Q&A format. Shame on you. All right, anyways. And then there's usually a follow-up comment saying, oh, yes, it is, or whatever. So you can call .length to get the length of it. You saw me use that in the for loop. What else can you do with an array? You could sort it. You could reverse it. You could get the index of a specific element, but notice that it says it's a static method. So does that mean that it's going to, can you do colors.sort? And no, you can't, right? That's going to be a syntax error. But that slide said that I had that method available to me. It did, but it's a static method, meaning that it applies to the class. As a whole, not to any object instance. So I would have to do colors equals array.sort. Please sort my colors array like that, right? And so array.sort, oh, and I looked at that, I goofed that, cannot implicitly convert type void to string. Ah, my mistake. You do call array.sort, but then you specify the array that you're passing in. So .sort is not a method that is attached to that specific instance. It is instead a method that's attached to the array class as a whole. So if it's a static method, you always precede the dot with the name of a class, rather than typing in colors dot and getting some particular method, right? Like copy to, or check to see if it's equal to a second array, and so on. Getting the length. Getting the length is a long. If you had an array that was more than 2 billion characters long, I mean 2 billion elements long, that would be interesting.
Wow.
Right, so
Super big.
string my colors is equal to colors.toString, right? Ooh, there we go. So now we could print out our sorted array if we wanted to.
What are the little dots under my for?
You know what? I don't know why I did that. Unnecessary assignment of a value to my colors. Well, say who? Say what? Probably it's because we haven't used that variable yet. We created it, we assigned it a value, but we never used it. Yeah, that's a little bit more old school, not using string interpolation. I don't have a placeholder. And now the underlining under my is gone because we've actually used that variable. It was telling us it was a useless variable because we had never referenced it after we created it. And let's run it, see how badly we've broken the code since the last time I run it. Sorted colors equals system.string. Now that's not what I wanted to see. When I called .toString, I was expecting it to have converted the array to a string. So maybe there's an array function that will build a string.
Let's see. Would it
not
sort
seeing
it
it.
alphabetically? Is that what it's going to do?
All right, one of y'all who are already experienced in C#, remind me how you convert an array to a string without it just giving you the name of the object. Because I'm disappointed in seeing that. Okay, fine, I can Google it. It's very possible I have to use a for loop, and if I do have to, string.join. Okay, no, I'm not gonna use a string builder just to create a new string. Here we go, here we go. That would do it. String dot join, and we create our array. All right, so string dot join. Please convert my colors array to a string and separate every value by a comma. And that's giving me some grief, which I am not expecting to see. Lowercase s, not uppercase. Still
The
not
comma
getting that
needs
to
to
work.
come before the colors. The separator goes before the.
Separator goes before the color sinks. Syntax in Python is weird. You just do this dot join because even a string literal is an object. I don't think even this language goes that far in making everything object oriented. Oh, it does. What do you know? All right. So anyways, all right. So now we should be able to print out my colors delimited by commas. Right? Blue, green, and red. I always tell people that they should learn about 3 programming languages, you know, 2 imperative languages like this, and then 1 functional language. And once you do that, though, once you learn too many languages, then you know the concepts, but sometimes you have to Google up the particular syntaxes. That's my excuse, and I'm sticking with it. Index of searches the array for an element, and it returns a -1 if that element is not in the list, right? So we have 3 colors. I want to find the position of green. My colors dot index of the word green. So what's a synonym for green? We're going to change the array at that particular point. So if green position is greater than or equal to 0 or not equal to -1, then we found it, right? We're going to change it, right? So my colors subscript green underscore pause is equal to chartreuse, and I'm probably misspelling that. Avocado. We're going to join the 70s. There we go, right?
Avocado.
Ew, he does not like me. Oh, my colors is a string and the array was called colors. I'm going to rename colors to color array, right?
Jeff, we're getting close to noon.
Yes, we are. We're going to need to break pretty soon. So color array at that specific position is equal to avocado. And we're also going to change the first value. We don't want it to be red, green, or blue. We want the first value to be purple. And then we can print it out again, right? We could print out string.join. What confuses me about that is there, okay, never mind. I'm not gonna bother talking about what confuses me. Use that as our delimiter, and then the array that we're printing out is the color array.
Join.
All right, so after this, we will have changed the value of green to avocado if it existed in the array. And then we're flat out going to change the first element. It's 0-based indexing, so we use a 0 there. And so it was blue, green, red, and now it's purple, green, red. Why did not green get changed to avocado? It's because I forgot that I had initial capped every value, right? So it was not found. So I should have put an else in here to explain that it was not found, right? But I can fix that by doing that.
Hmm.
And it blew up. What was my exception?
Your else probably should not have been separated out there, should it?
Index was out of bounds. Oh, really? Well, let's print out green pause and then we will probably break. All right, so let's stop our debugging by pressing the little red square. So found it at position green pause.
Still didn't like it.
Now green was found at position 5. All right, my mistake. I started using a string, then I started using an array, and of course it is at position 5, is it not? So some of this stuff was predicated on the idea that it was an array, and
Did
some
it
of it
count
was
the commas?
predicated on the idea that it was a string. And so by mixing my paradigms, I've totally garbled it. I'm going to remove some of this stuff. That won't work, but we could change the specific character, right? My colors. Tell you what, let's just fix all that. Delete all that. We leave it alone. All right. So that's treating a string as an array, right? But we checked the my colors array. We found its index. You know what? I should undo all of that. And I believe that if I just done colors array there. Gonna come back to that. Let's take lunch and we will reconvene at 1 o'clock. So you have time to drive over and go to the drive-thru McDonald's or whatever you're gonna do.
Have to do for 12:02. Is it all right just to leave this running, Jeff?
Yeah. Why don't we just keep everything running? Not find. That's the method that I was trying to think of.
Find.
Is that okay?
Going great, going great.
Good.
Oh, start video. You, can you hear me, Jeffrey?
I sure can, and you can hear me?
Uh, yes, I can.
All righty, good deal. So why don't we pick up where we left off? Pretty soon, we're gonna wanna stop going through the C# PowerPoint because, you know, this really isn't learn absolutely everything about C#, and we're gonna talk about doing the unit testing. But let's take it a little bit further. So I went and I added some comments to the code that we had already written, looking at it. So I'm gonna upload this now so you can go and grab it if you want. Right, I just kind of expanded what we already had, talking about string interpolation and how you can have expressions there. And that little bit of code where I was trying to search the array, I was just being an idiot and searching the string rather than searching the array for the word green. So it was telling me the index where the word green appeared in a string. Instead, we needed to use array.indexOf, right, to actually search the color array for the search string. So I updated that code. And if we did not find it, it returned an index value that was negative. So we did not try to change that search, did not try to change the array. But if we did find it, then green pos was the index value, the subscript, you know, for the element that contained the word green, and we replaced it with the word avocado. So had to fix that, had to actually make it work on the array itself and not the string.
Can you show that new code, Jeffrey? Your screen's not up.
Yeah. How about if I show the screen? That'll help a lot.
Oh,
All right, we good to go now?
okay.
So
Did
pretty much
you-
everything stayed the same except for that, right? Because I was I was searching the text version of it that we created by using .join. And so now we're searching the array itself. So let me upload this. And I'll distribute it via the chat as well. All right, why am I not seeing the chat? There we go.
Michael?
All right.
Michael.
So as mentioned, these methods are static methods, meaning that they apply to the classes at whole. So they're prefixed by the name of the class rather than the name of the object. And so array.reverse would reverse the order of the array. We used array.sort. Let's sort it and then reverse it so that the highest number, the highest letter, purple, I guess, comes first. So array.sort. The name of our array is color array. And then let's reverse it. Since these are static methods, they're prefixed with the name of the class, but if they were non-static methods, then you prefix it with the name of the object itself, the variable containing the reference to the object itself, right? So like if you're going to copy to it, or you're going to get the length of it, or something like that, index of, we use that up there, did we not? Oh, no, that's a static method as well, but it has lots of properties attached to it. Get length, right? Copy to. Want to copy that to a new array of strings? We can certainly do that.
Could you print
Copies all
that?
the elements in the current one-dimensional array to the specified one-dimensional array. So why don't we create a new array of the same length? Nah, you get the idea. You get the idea.
Can you just print that? Yeah.
Yeah, why don't we just print the value out as it currently is after sorting and reversing. All right. And so now it's red, purple, and avocado. If we create a new string, a new array with 3 elements, got to give it a name, color copy. Then we could copy the old array into it, right? Color array dot copy to the new array, right? Color underscore copy. Now there are other ways of doing that, starting at index 0. So now color copy will contain the new one. Or we could just have done this. Color underscore copy equals color array dot clone. And that way we would not have even needed to allocate it to the correct length, right? String color copy to equals color array dot clone. That doesn't seem to be working. Color array dot clone. These methods don't know what they are going to return. .clone does not know that it's returning an array of strings. All it knows is it's returning an array. So you have to cast it. Casting it converts the result of this method to be a pointer, a reference to that specific type. Just like if you had this, right? You have an age variable, and then somebody typed in their age, as a floating point value instead. They know that they happen to be 33.8 years old for some reason. Why is this underlining everything? I wish you'd stop that. Oh, because I'm in debugging mode. Stop that. All right. Good. Now it's done. All right. So that's called a cast. A cast takes a data type and attempts to do a conversion to another type. Now, if the types are too dissimilar, like you're trying to convert to a string, you can't do a simple cast. But an array reference, a generic array reference, an array of objects, which is what .clone returns, can be converted into a reference to an array of strings by casting, just like we converted this floating point value to an integer like that.
Now, did that come out as 33 or 34?
INT does a flat truncation of it, so it'd be 33.
Okay.
It doesn't round upwards. It just loses the fractional component.
Yeah, it's just like a trunk.
Right. So data manipulation, There's really no mysteries here. Algebraic expression, x plus y, 3 times 4. Sometimes people haven't encountered modulus before, but if you've taken a programming course, you know what modulus is. It just means remainder, right? 5/3, if they are both integers, right? Int A1 is equal to 5/3. Well, these are both integers, so 3 goes into 5 one time. And yeah, there's a remainder, but it goes in there one time. And then the remainder of that is 5 modulus 3. Well, when 3 went into 5 one time, the remainder was 2, right? That's all modulus means. And this is the quotient, right? That's the integer quotient. Now, the only reason it rounded it down, the only reason it truncated it is because these were both integers. If one of these was a float, it would not do integer division. Whoops. Oh, come on. It would do floating point division, which is great, except for the fact that we're trying to store it in an int anyways. And so we would have to cast it anyways, and we would lose the fractional value. So why don't we just get rid of the 0.0 and accept the fact that this is going to return an int. And so 5 divided by 3 is equal to 1.666, and it would drop that down to be a 1. So arithmetic operator precedence. You're familiar with the idea that multiplication and division happen before addition and subtraction in a string.
Still goes left to
Not in
right.
a string, in an expression. So if you do, you know, one plus 2 times 3 plus 4, how does that get grouped together? What gets done first? The 2 times 3 gets done first, right? Because of operator precedence. So this is evaluated as though it had been written like that, right? It's like you grab your TI calculator. If you typed in 1 plus 2 times 3 plus 4 before you hit the enter key, then it would do that multiplication first. On the other hand, if you use it like a $10 calculator and you type 1 enter plus 2 enter times 3 enter, right? Then it'd just be straight left to right. So the highest precedence is a prefix increment and decrement, plus, plus, and minus, minus. The lowest precedence is postfix increment and decrement. Well, what does that mean? What if you do this? Int j comma k, right? J is equal to 5. K is equal to j plus plus. What are they equal to afterwards? Are they equal to 6? No, they're not. Because if plus plus is a suffix, if it follows it, then it's the very last thing that happens in the expression. So the order that happens is the 5 is copied into the k, and then, excuse me, the j. 5 gets copied, yeah, that was correct. 5 gets copied into k, and then j gets incremented. So then at that point, j becomes 6, which is counterintuitive, right? People see the plus plus and they think that it happens first. No, it only happens first if it precedes it, right? Prefix increments and decrements are at the very top of the heap of operator precedence, right? So if you read this, j gets updated first. So j turns into 6, and then it goes across the equal sign to fill in k.
You print those and you get rid of those dots.
Yeah. So if you could always just do them on their own lines, right? And that removes any ambiguity. Yeah, I'm tired of seeing them. being underlined as well. Yeah, that fixes that. Output's not going to make a lick of sense to anybody looking at it, but it fixes it. All right. All right, we're going to need to start talking about classes pretty soon. So strings we've talked about a lot. Yeah, string S is equal to Bob, string S is equal to new string Bob. That creates a new string based on that. Not any real reason to do that as far as I'm concerned. We know what \n and \t do, new lines and tabs. If you're going to convert to numbers, you use int.parse. Unlike C++ and Java, they both have the ability to convert user input from the console directly into the desired data type, right? You can call next int in Java and it'll give you an integer. You can call next float and it'll give you a floating point number. In C++, if you do cout arrow arrow and you give it a floating point number, right? If you do this, double D, and then you cin into D, cin converts it to a double on the fly, right? Or in Java, you know, if you use double D2 is equal to scanner.next double, that returns a double. However, C# readline method always returns a string. That's just a fact. So if you do something like this, let's display a message asking them to type in a number. Enter a temperature in F. Let's just make it a write, and then we can give them a place to type, right? Like that. And now we need to read line. So let's create a variable. We want to allow them to type in decimal points so that they can type in 98.6. And then let's read line, but unfortunately we can't do this, and I wish we could. Console.readline doesn't work because this always returns a string. So we have to create a temporary string variable to hold the results, and then we can do that, right? stemp is equal to console.readline, but now we got to parse it. Come on, go away, stop. Okay, get rid of it. Parsing it means converting, right, from a string to the number. So we can use double.parse to convert that string, right? So tempf is equal to double.parse the string. Now that's not the best way to do it because it'll crash if the input is improperly formatted. There's a version called safe parse or try-parse. It's called try-parse, which is actually the correct one to use, but it's a little bit more complicated to express, so I'm not going to, right? So C# always returns a string when you call console.readline. So the input must be converted to the type of choice, right? With int parse or double.parse or whatever. Now, what if you did that so often that you wanted to come up with an abbreviation for it, right? What if you wanted to do something like this? Double temp2 is equal to, and you really wish you had a function like this, right? Read double. Well, you could write your own function that does that. Let's do that. Let's go up here and add a static method. Well, I guess we can do it down at the bottom. It doesn't really matter where we do it. So underneath this method, I am going to add it up near the top. Right where we've defined these other methods. Static, so that we can call it without creating an object, right? So we can just prefix it with a class name. And what did I call it? and I
Read
want it to
double.
return a double, and so I call it read double, and it just does the same thing, right? String S, S is equal to console.readLine, and then return double dot parse S, right? And we could do the same thing for int if we wanted to. We could read an int and so on. Now, I'm not going to actually invoke all these because by the time we have too many versions of doing input, right, we ask too many questions and it becomes more and more annoying each time I press play. I'm going to have to type in something, right? But hopefully that gives you the idea. You can always encapsulate functions. If you get tired of typing console.WriteLine, you can make a function, a method, excuse me, called WriteLine, right? And then you could, or print. How about print? Static void print, and it takes a string, and all it does is call console.WriteLine to print that string out. Now that we've done that, our code can look like this. We can tell them what to do, right? Print, enter a number in Fahrenheit, right? Now that's ignoring the fact that it would print out the whole thing. I mean that it would add a character term to it. I'm not going to bother fixing that, right? We could call it print ln like some languages do. I believe the C language does. And anyways, so there, we can write our own functions to encapsulate functionality that we wish we had. So if we go back in and we inspect what we have here, we have three functions that we've attached to our class. Our class is just called program. Visual Studio chose that when we made it. And since they are static, they can be invoked without prefixing it with the name of an object. Well, what if it didn't have that static keyword? Let's make a new class called fraction. What does every fraction have? It has a denominator, but I'm just going to be childish and call them top and bottom, right? And I'm going to make them public.
Our budget, we're gonna be able to replace these chairs.
Sorry, that colon is C++, not the correct syntax here. All right. And then I'm going to make a method called setTop or setDenominator, right? So it doesn't need to return anything. SetDenominator, or how about one called getValue, right? Like I said, the convention for C# programmers is to make all their methods with a cap letter, whereas every other programming language I've seen, the convention is to label, you reserve capital letters for class names. So anyways, we're going to get the value of our fraction. So let's get a result, right? It's a result, and the result is equal to this dot top divided by this dot bottom. And then we return that result. And know that this keyword is not strictly necessary. I like typing it because when I type in this dot, it gives me a list of all the members of the class. And top and bottom happen to be two members of it. So it saves me some confusion about typing, right? I don't ever make any typing mistakes if I do that, but it's not strictly necessary. But hopefully it's readable. This object's top value divided by this object's bottom value. Okay, so if we were going to use that in some code, since this is non-static, it's an instance method. Meaning we have to have an instance. We have to have an object to use it.
Anyway, it's just stupid. It's just
Right? Because how could you call getValue if top and bottom had not been set? We don't have any data. It doesn't make any sense to call getValue. So in main, I'm going to create a fraction, right? I'm going to go down to main. fraction F1 equals new fraction. The new keyword is necessary to create the object, unlike C++. There are no pointers in this language, so we don't have to worry about differentiating between the dot syntax and the arrow greater than for you C++ programmers. Somebody may be able to prove me wrong about pointers, but I think that's the case. And then let's set the top and the bottom. 1, F1 dot bottom is equal to 2. Now let's get the value of it. I guess it's not public yet, so I can't access it. So that's going to be an error. If you do not specify that a method is public, it is considered private and only accessible to other methods within that class. So way up here where I declared fraction, I should have also made this public. Now there's a programming error here, which is that this is an int divided by an int, and an int divided by an int gives you an int rounded down. So we need to convert one of those to a double, right? That would do it. Convert this dot top to a double before we do our division. And if we wanted to be pedantic, we could do both, but only one of them is strictly necessary because a double divided by an int gives you a double, right? So as long as one of the operands of the divisor of the division operator is a double, is a non-int, then it won't do integer division, which you usually don't want, right? Usually if you do 5 divided by 2, you want to see the proper result, 1.25 or whatever it is. That's not right, 2.5. Let's go and I guess we better print our result out in order to test it. Where is our fraction created? All righty. Now I made it public, so that should fix it, right? Now what are you complaining about? Okay, good. Went away. Now let's just put a console.readline here. You know, pause, press enter, and then console.readline, because now I'm going to be adding things to it and I don't want to see all that old output. So I just wanted to pause, right? Not even going to store the input. I just wanted to pause there. I haven't printed out the value of the fraction yet, so I want to do that, right? Well, I made a print function. There you go, right? Since the print function is expecting a string, if you have a string and you add a non-string value to it, C#, like Java, converts that to a string. So it calls a toString method on that integer, excuse me, on that double to convert it to a string and then concatenates it to it. So that's actually like the easiest syntax for converting a number to a string, right? You don't even have to call a toString method. You could just append that number to an empty quote. And then when it's done, that silly will contain a string version of 1.23. It's just a shortcut. Okay, so anyways, let's print it and see what 1/2 is. Make sure our code works, right? So the value of the fraction is 0.5. Since getValue is a non-static method, we had to create an object in order to use it, right? So it's not preceded by fraction.getValue, right? We don't call it by the name of the class. That would be a class member, a class method, a static method. I want to grab something, make sure that I do this the way that I've been planning. All right. So we started talking about classes before the PowerPoint showed you. I'm hoping that you've used languages before that have the idea of classes and objects, and so it's not brand new to you, that you just needed to see the syntax. And fortunately, C++ and Java have rather similar syntaxes to C#. for declaring your classes. It looks more like Java's way of doing it than C++. There are some differences. But all right, let's go back. Whoops, wrong one. All right, so two ways of converting a number to a string. You can just add it to a string and it converts it, right? Or you can use string.format, which does that placeholder business in a slightly different way. Or you could use, well, fine, an interpolated string, right? Now this would be absolutely silly to do it this way, right? But you could do that. Pretend that 1.23 is a variable in this case. That's what it should have been, right? Double V is equal to 1.23, and then add, V to your string, or call string format and pass it in to fill in placeholder 0, or your string interpolation to get the value of it. Yeah, space wound up there. So parameters, function parameters. By default, parameters are passed in by value. They're passed in by copy. So I'm going to write a function. I've done this already, right? I wrote a function called print. When I call the print function, the contents of the string that I'm passing in as an argument get copied byte by byte into this string. In a way, that's kind of a waste of speed, right? Because a string could be 1,000 characters long. It could be 100,000 characters long, right? And so every single time we call print, we're going to be copying the entire copy. Well, yeah, we could, but we could also write it like this, where we take a reference to a string. What is a reference? Here, this parameter variable gets a copy of the argument. Here, when we call the print2 function, when we call the print2 method, it's actually going to get the variable itself. It's the difference between me handing you a copy of my term paper and me giving you my original term paper, right? So that's a little bit more risky, right? Because if I give you my original term paper, you might change it, right? So this function is going to print it, but for some reason we're idiots and we're going to also be erasing the string after we print it out, right? If I put my semicolon, that'd work a lot better. Up here, if I did that, it would not affect the calling code. Sorry, there's a word ref supposed to have preceded. You're giving me syntax errors there. Yep, that's going to make it go away, is it not? Yeah, all right. So this means reference. It's a reference to it. So when I call it, I'm going to write just a function called test print. If I create a string, string name is equal to Billy Bob, and then I call the print function on it, and then just out of curiosity to see what this print function did to it, I'm going to print out that string. Oh, that needed to be declared as void because we're not modifying anything. We're not returning any values. Okay, so let's print out after print, comma, name equals name, right? And we're going to find out, I'm going to change the order of these so that both chunks of code are on the screen at the same time. That after we call print, even though it looks like we're resetting the value of the quotes, even though we reset S, All we did is erase a local variable. String S, this parameter variable is a local variable. Its lifetime is between here and here. Its scope is between there and there. And any changes to it do not modify the original variable. So when I run, if we called test print down in main, we're going to see that name remains Billy Bob even after that call, right? So after the print, the name is equal to Billy Bob. How about the other one? This one takes a reference to it. So if I call print to name, that syntax actually is not going to work. I'm going to have to make a change to it. I'm surprised it's compiling. No, it's not. All right. You have to tell the compiler, and this is not true of C++, but it is true of this language. You have to say, oh, you're a reference. And so the type that is defined here as a reference variable has to be indicated here. But that's actually a good thing. Why? Because when I'm writing the code, I would like to be warned in advance that that function has a possibility of changing the value of my variable, because I'm used to being able to pass in variables and not have it change. All right, so now when I run it, we're going to see that after the call to print2, it is definitely different. Since print2 resets that variable to S, it actually is changing the name variable. We're not passing in a copy. I'm giving it my term paper, and if it erases my term paper, I'm out of luck. Let's go ahead and run. All right, and so it printed out with print2 a second time. It printed it out, but then it erased my variable because of that. Whereas that had no effect when it was not declared as a reference. Now I am going to get rid of that because it's stupid, right? And I'm going to get rid of that because we've proven the point. If it's not going to change it, but you want to pass in the variable itself instead of a copy for speed purposes, you change that to IN. Right, so let's go with a couple of different things, right? We could have void, I don't know, test reference, and it's going to take a reference to a variable, right? And it's going to change it to the value 3. I'm going to make it static because if you're in a static context, the only other methods that you can call in the same class are also static. So then we're going to do static void test underscore ref2, which takes an input reference. What does that mean? It means it can use it, but it can't change it, right? Can't increment it, can't assign it. It's underlining it now. It took it a while for it to realize, but that's a syntax error because we said that this is input only, right? We're doing that for speed purposes so that it doesn't get copied in. All the 1,000 bytes of my, my array or whatever don't get copied in. Instead, it gets the actual variable itself, but we're promising that we're not going to change it. And we're not doing the promise, the compiler is doing the promise, so we can kind of trust it. Can't do because X is an in ref input. There's also in later versions of C#, including the one that you'll get if you install any recent version of Visual Studio, a version called out. And what does out do? Out means that it's only, wait, is it out that was declared all along and in that was just added? Anyways, an out reference means that no matter what gets passed in, you are guaranteed it's going to change it. Static void test underscore reference 3. And let's use our variable int y is equal to x. We promised that we were going to change this because this is an x variable. Excuse me, it's an out variable. And we didn't, so now it's a syntax error. The out parameter must be assigned. Right? Has to be assigned because it's an output variable. And here it's complaining because since it's an output variable only, we didn't even pass in any data. So how could we do that, right? So really, this code up here should have been written as an out rather than a ref. Ref means it's a read-write variable, right? In means it's input only, and if you try to change it, it won't compile. Out means it's output only, so if you don't assign it a value, it won't compile. So reference types. Ref equals input and output. It can do whatever it wants to with it. In means input only. Code can't assign a value to it, or the method can't assign a value to it. And out means out only. The method must assign a value to it. Java does not have reference types. Python does not. C++ does. So depending upon which language you're in, you may have experienced reference parameters or not. The only problem with reference parameters and using them for speed is that you have to add that ref word when you call it, right? Where did I do that? Oh, inside test print. Right? You have to add that. Well, if name is not going to be changing it, we would just make it an out. And so I'm going to come up here and make my print2 method an out because we're not changing it, right? You're not supposed to change anything inside a print call. Oh, sorry, in. Input only, right? Because we're not changing any of the values. So I'm going to come down here and make that an in. If passing in large objects, it's a good idea to make the parameter variable a ref variable. Use in if the method is not going to change any of the data. Make sense, gang? Hope so.
Okay.
I'm watching the class. The time, we are going to want to kind of skip ahead to unit testing. We've talked a little bit about classes. I did not fluff out the fraction class much. So that's going to be what we do before we start talking about unit testing. What I would like to be able to do, and what I can't do, is right now when I create a fraction, I have to do this. Fraction f is equal to new fraction, right? And then I have to say f dot top equals 1 and f dot bottom is equal to 2, right? That's what I have to do. I sure would like to be able to do this. Fraction f2 is equal to new fraction and specify those values. Well, that requires what's known as a parameterized constructor, a constructor that accepts parameters. So let's add that. It's going to be public or else we wouldn't be able to call it from outside the fraction class. Fraction, and it's going to take a top value and it's going to take a bottom value. I might rename those to denominator and numerator when I'm done, right? Because those names are kind of silly. I might right-click on it and change it to numerator and so on. And so then when we call that, we're going to set this top equal to the top argument that's passed in, and this dot bottom equal to the bottom argument that's passed in. Now that I've done that, I've broken my code. I made it more convenient to use, but that breaks the original place where I was creating a fraction. Because once you add a parameterized constructor, the default constructor that doesn't accept any parameters no longer exists. And that's also true of C++ and Java. So I'm also going to create a default constructor that doesn't have any parameters, and all it does is set it equal to 1 over 1, right? I don't want to leave the values at 0 because if I created a fraction and then called get value, and the value in the denominator was 0, it would crash, right? Division by 0. So here we go. Now we can call it both ways, right? We can create a fraction by passing in arguments or without any. Let's scroll down to main and play with that, right? So we created one fraction that way. And I'm just going to do this fraction, or F1 is equal to new fraction one over 3, right? And then let's get the value of it. Forgive me for just copying and pasting these two lines. All right. So now it's going to print 0.333 or whatever, right? After a certain number of places. Who knows how it's going to be formatted. But we were able to create a fraction in one line rather than 3 that way. All right, you C++ programmers may be saying, okay, you've got a memory leak now. And what would that memory leak be? It would be the fact that I'm creating a new object without deleting the old one. And you Java programmers would go, oh, whoa, what? You're not deleting an object. Yeah, I am, because I'm reassigning this reference to point to a new area in memory. So the old one is now orphaned, right? Nothing is pointing to this old fraction that we created. However, C# is a garbage collected language. There's a garbage collector which goes, and when memory has no reference, when an object has fallen out of scope, when nothing is pointing to it, if it's been reassigned, it's no longer of use, then C# will release that memory so that you don't have a memory leak. So there is no delete call like there is in C++. You don't have to say delete. Ooh, look at that. Delete F1 after you free it or anything like that. Okay, so what else does a fraction class have? Well, how about we write a simplify function? Right, the simplify function. Well, for us to simplify, we need to figure out the greatest common factor between the numerator and the denominator, right? So that we can turn 2 over 4 into 1 over 2. So we need a greatest common factor function. Method, excuse me. So I like to leave my constructors up at the top. And I did not do that here. So I'm going to cut this get value and paste it below the constructors, right? So this is, it's close enough to saying that this is the default constructor. It's not really. The default constructor is what gets provided if you don't provide any constructors. But if it doesn't accept any parameters, I call it the default constructor, even though that's not 100% correct. And this is a parameterized constructor. Now let's write a greatest common factor function. Do you need a fraction, though, in order to calculate a greatest common factor? Well, it might be useful to be able to calculate a greatest common factor even without having a fraction. So we're going to make it a static method. Public static int GCF, which takes two values, right? X and Y, or V1 and V2 and whatever. All right, now I'm just going to copy some code that I've written previously rather than recreate a GCF function. So int x, what, is equal to math.min, the minimum value of v1 comma v2, right? So if we pass in 2 and 4, then x is going to equal to 2. And int y is equal to math.max of v1 and v2. Right? So if we pass in 2 comma 4, then x is going to be 2 and y is going to be 4. And now we're going to use a for loop to figure out which the greatest common factor is. So we're going to go up to, and this may not be the most efficient way of doing it. We're going to start off at 2 because we already know that 1 is a plausible factor, right? So let's create a variable called factor, and we're going to set it equal to 1. And then we're going to start testing at 2 and above. It wouldn't break anything to start testing at 1, but just slightly more efficient if we do that. Keep going while value is less than or equal to y. I think we could actually do it too, where value is less than or equal to x. No, I think I've made that mistake before. And each time, increment the value by 1. So we'll be testing, if we passed in 2, we will try to divide both values by 2 and 3 and 4. I really am sure that we could just go up to the minimum, in which case we could test it against x rather than y. But this works. I've tested it. It's just not optimized. So we're going to divide x by the current value of our counter. And if the modulus of it, if we get no remainder, then it's evenly divisible. And Python programmers are used to using the word and there, but everybody else who uses a C-based language like Java or this are used to using the ampersands for and. And y, modulus the value is equal to 0. That means it's evenly divisible by both values, right? In that case, it's a factor. And then we're going to return our factor. So how are we going to simplify it? How do you simplify a fraction? You calculate the greatest common factor and you divide both the top and the bottom by the greatest factor. So if we pass in 2 and 4, what's the greatest factor between those? 2.
2.
So if you have the fraction 2 and 4, 2 divided by 2 is 1, 4 divided by 2 is 2, and so it simplifies to 1 over 2. So public, this is not going to be static because it refers to the fraction itself. It's not a generic math function. Simplify, please simplify our function. So let's get our factor. Our factor is equal to the GCF of the top and the bottom. And we could make it return a fraction when we call simplify, but when we call simplify, we're actually simplifying this fraction. So let's leave that alone. And so top divide equal by the factor and bottom divide equal by the factor, right? So our constructor, if we construct it, let's simplify it afterwards. So if we pass in 2 over 4 or 3 over 6, it becomes 1 over 2. So after we set the top and the bottom, we simplify it. Let's try it out. Down in our main code, we created a fraction or 2, right? One fraction was 1 over 2. Let's make it 2 over 4. When we call get value, it's going to print 0.5 no matter what though, right? We don't actually get to see what the top and the bottom are. And here we might have wanted to make this 2 over 6 to see if that becomes 1 over 3. Well, we need something that's going to convert this to a string, right? If we just try to print the fraction, I'm going to go back to using console.writeLine, right? Because it looks more familiar, right? Fraction F1 is F1, print it out. Well, it's not going to print out anything we want to see. Why? It's just going to print out its name, right? The value of fraction F1 is 0.3, right? The value of fraction F1 is 0.5, but when we try to print it out directly without calling it value, it just gave us a class name, right? Aerospace3 demo 1 fraction. We don't care about the class name. So we need to give this thing a toString method. ToString will convert our data inside the class into a string so that for easy printing. So here's the end of the fraction class. So keep things straight in my head. And so we're going to do public, and we are overriding the default toString method. So we're adding the override keyword. In Java, it'll compile even if you leave that word off. I'm not sure if that's the same in C#, so I'm going to leave it there. And what does our string look like? Well, it's just the top over the bottom, right? So we're going to return curly brace top in curly brace, followed by a slash, curly brace bottom in curly brace. Why are we doing that? Because I want to actually see the words, or 1/2 or 2/4 when I print it out without calling get value. And I believe that's what we're going to see now. Yeah, and so our fraction is equal to 2/4. Looks like it didn't simplify it correctly. The reason why I did not simplify it correctly is because I changed the values of the fraction if I scroll down into main, I set the values of X and Y, of top and bottom directly. And I never called simplify. Maybe the print function should simplify it. Right, so let's go and modify our toString method. And yeah, there are other ways we could try to accommodate this, but I don't think it's going to hurt for us to simplify the string before, simplify the fraction before we try to print it out. Now, honestly, we should implement this in such a way that with proper encapsulation, main cannot change top and bottom directly. But we're not going to do that. All right. And so 2/4 turned out to be 1/2, right? Now let's print out the other one, which we didn't print out already. Right? And so since this one was 2/6, is simplified to 1/3. All right. It's about time to start talking about unit testing. And you Mac users realize that you're going to have to follow a slightly different scheme. You're going to have to follow the steps in the PowerPoint. I don't have my Mac here, and we wouldn't have the time to repeat this for both. However, you can try following the steps in the PowerPoint. And like I said, you can text me. My phone number is, go ahead and write it down if you want to play with it tonight. And it's all right to wait till tomorrow, is 405-898-7767, right? Feel free. All right, so going ahead to the unit test section. Feel free to read the rest of the PowerPoint, right, guys? Because there's a lot of stuff, but of course I covered a lot of it, right? Like what a class is. A class is just a collection of data with functions attached, and you call those functions methods. Class constructor, I talked about that. Here's our fraction class. It's got a denominator and a numerator. All right, so putting it all together on Windows. Create our project. Don't change the framework setting, and click create. I've done that. But maybe I ought to start fresh because I have some sample code right in here. So I'm going to do that. I'm going to follow my steps. File, new project. Oh, the program's running, so it won't let me make a new one. Press the little red square to stop it. File, new project. Make it a console app, a net framework app. You're going to follow slightly different instructions if you're on the Mac. You don't choose .NET Framework. I think you choose .NET Core. let's use, okay, I'm going to call it Aero3 sample. Then I'm just accepting all the defaults. All right, now I'm going to come in and look at my PowerPoint. I've clicked create. On the Mac, you choose .NET Core App Console application, right? Choose a template for your new project, .NET Core App Console application. Okay, now enter this code. Note it is included as text on the next slide, so I can just copy and paste it. So I'm going to go to the next slide and I'm going to grab all of this, right? I'm just going to hit Control A, Command A on the Mac, and highlight it all, right click and choose copy, or choose Control C, Command C to copy it. And I'm just going to replace the entire contents. And the only reason I'm doing all this is so that I have exactly the same setup that you do, right? All right, so you'll notice at this time, numerator and denominator, right? I call them by their proper names. Here's get value. It doesn't look like I've got a simplify function here. That's all right. I could just copy it from the other one, couldn't I? Let's keep going. So I'm going to press start to run it just to see if it runs. What does it do? It just creates the fraction class, creates a fraction with a value of 1/2, gets the value and displays the result. That's what it does. And so when I ran it, it did not pause. So again, I'm going to add a console.readline at the bottom of it. Maybe the console.writeline. Done. Press enter. Look at that. This stuff needed to be inside main, and I put it below the curly brace. I'll do that. There. Maybe even a couple of new lines there. All right, and so it uses the fraction class. The fraction value is 2. So I need to change the class to be public so that the testing framework can access it, because our unit tests are going to be contained in a separate class, in a separate file. And if we just like those methods, I had to mark them as public so that they could be called from the main. I need to change the class itself because it's going to be in a different namespace. So I'm going to come up here and make this class public class fraction. So far, I haven't deviated from the instructions except for adding these lines here. Press enter and then read line. I should just put that in the source though, right? I should update the PowerPoint. Okay. All right. And now, if you're on the Mac, you actually have to add the test framework. It's included by default on Windows. It's not included by default on the Mac. So go to slide 72 on the Mac if you're doing it, and you right click on the solution and do add new project. What kind of project do you add? You choose a in-unit test project. And then click the next button a couple times and name the project fraction test. Then you have to add a dependency to your project to relate it back to your original code. And again, Windows does this by default. So Windows users can sit here, you know, and look smug for a little bit. So you got to add a dependency to your sample one project by right-clicking on dependencies and choosing reference. Select sample one and click OK. Something's bugging me about what I'm seeing here. You add it to your fraction test project. That's a mistake. I definitely need to upload the modified PowerPoint, right? Because we're right-clicking on fraction test dependencies and adding that we wanted a reference to our original project. Not sure where sample one and sample two came from, but the project's going to work just fine. All righty. Adding the unit test on Mac. When you did that, it created a test method that looked empty, and you're going to modify your code to look like this. Let's take a look at it. It's a test function, just like I did in Python this morning, right? That creates a new fraction, and it says the result is equal to get value, right? And then the target, what we expected it to be, was 0.5, because 1 divided by 2, the value of that is 0.5. And then there's an assert. Assert that these guys are equal. Assert.are equal target and result. And if it fails, it's going to blow up with the message get value failed. And you Windows users, we're going to get to do the exact same, and we'll see that the syntax is a little bit different. You could, on Windows, add the in-unit framework to your project, and then the syntax for this would look exactly the same. But like I said, it's not the default. So you can run the tests, again, on the Mac by going to the Run menu and choosing Run Unit Test. Okay, now we're on Windows. Adding the framework on Windows. It'll do it for you. All we got to do is right-click on the code and choose Create Unit Tests. That makes it all too easy, right? So I'm going to right-click somewhere in my code and choose Create Unit Tests. Create Unit Tests is only supported on a non-test project within a public class or public method. Well, the main method is not public, so it's complaining about that. But really, I wanted to test a sample class. So I'm going to right-click on, for example, maybe the get value method and choose Create Unit Tests there. And it's going to create the MS test. It's going to use the MS test version 2 framework. We could install in-unit, you know, as a test framework, so it would look exactly like the Mac, but I'm not gonna. And then I'm just going to click OK. Accept all the defaults. Sure, save changes to my projects. All right, back to my PowerPoint. Right-click on your code and choose Create Unit Tests. What I'm going to say is right-click on your code in the Get Value method and choose Create Unit Tests. And what did it do now that I've done that? I don't know what that's there for. All right. Value does not fall within expected range. If you get that error, ignore it. Sounds stupid, but if you get that error, ignore it. And then if we look at our Solution Explorer, we see a new project was added, Aero3 sample tests. And the CS file, the C# file that it created is called fraction tests. That was one of the things that we accepted the defaults on. And let's look at it. Here's get value test. Well, it's supposed to create a fraction, right? Now we're writing unit tests. We want to test the get value function, method. So let's do that. Fraction F1 equals new fraction. And by the way, this entire thing is being recorded. I've recorded the entire lecture. And so if you can sit through 7 hours of lecture and, you know, whatever, I'll be posting a link on Canvas once the almighty upload is done. Wish me luck. All right. And so let's pass in 1,2. This version of the fraction class does not have a default constructor. So when I tried to create it without specifying any values for the denominator and numerator, it did not work. All right. So what's our target? Our target value, 1/2, should be 0.5, right? But what is our actual value? You know, I'm kind of winging it and I should go and check. That's not what we need. I should go and check the actual PowerPoint to make it precisely the same. Yeah, so if you get the error shown, it's because no public classes were found. Create unit test is supported only on a non-test project. That's because I was trying to do it on my main project, which was not a public project. When I went back and did it on get value, it worked. But if you did not change the fraction class to be public, then you need to do so. All right, this is after we create our add unit tests, accept all the defaults and press OK. If you get an error message, it probably worked anyways. And I haven't researched that error message to find out if it's specific to mine or not. I wish I'd screenshot that error message, but I guess I could recreate my steps. Okay, so Visual Studio creates the test class, but we're going to modify the fraction test method. Here's what it looked like before I started typing. Here's what it looks like afterwards, right? New fraction 1/2. The result is equal to f1.getValue. The target is 0.5, and we're going to assert that they are equal. Assert.r equal target comma result. And then an error message. So let's finish this up. So the double result is equal to f1.getValue. Naming convention, I should have called that an uppercase G in order to be a good C# programmer. I could right click on it and choose rename and it would rename it throughout the project, but I'm not going to deviate from the code in the PowerPoint. And now we need to assert. Assert.r equal, and we want to make sure that the target matches the result. Target, comma, result, comma, get value. What kind of message do I want to display? Okay, failed, good enough. So there's our assert message. And if this was not running in a test framework, then assert would of course actually generate the failure, right? I mean, it would create an exception and it would stop the progress of our program. It would crash our program. But since it's in the test framework, then it's fine to do these asserts. It's how the test framework knows whether it succeeded or not. All righty, I'm about ready to run this test and see if it worked. So I'm going to run the test using the test menu, different than the Mac where you chose the run menu and test was at the bottom of the run menu. So there's a test menu in Visual Studio Windows. I'm going to choose test, run all tests. Takes a little while to run. It built quickly. I'm not sure I saw it succeed or not. Test Explorer. So test Explorer. It seems to be saying that it failed the test. Which test did it fail? Took 155 milliseconds to run it. go and look. I don't see why I should have failed. All right, let's explore. Press the down arrow, sample one test, fraction test, get value test. It expected 0.5 and the actual value was 2. Well, so our function does not work. I'm probably inside get value dividing the denominator by the numerator rather than vice versa. So this was actually an expected failure, right? Because it was coded incorrectly. And maybe my very next slide said that, right? The test will fail because get value is broken. It's doing integer division, which rounds down. Yeah, and that's not the only problem, is it? The problem is that the terms are flipped. So get value failed. It expected 0.5. Let's go and fix it. So I need to go to get value, which is inside program.cs. I need to take another look at it. Now see, that's actually looking okay, right? Numerator divided by denominator is, my constructor is wrong. Here, it's expecting the denominator to be the first parameter, which is not logical. So I need to fix that, and I need to fix it in the notes as well, because that was not what I intended. The problem that I intended to have is the fact that it's not doing a cast. So now when it runs, it's going to say that it failed and that get value is 0 because 1 divided by 2 converted to an int, 0.5 rounds down to 0. All right, so uses a fraction class, a fraction value is 0. No, it's not, but let's run the test anyways. Run all tests. Succeeded, failed, right? It ran the project successfully, but it did not pass the test, so that's misleading. If we look down here at the taskbar, it says 1 total test, 0 passed, 1 failed. And so if we come up to View Test Explorer, again, it looks a little bit different on the Mac, we see that the actual value was 0 and the expected value was 0.5. And the reason why is it's doing integer math. So we need to convert one or both of the operands to be doubles. So let's do that. I'm going to go back to here, get value, and convert that to a double. And just to be compulsive about it, I'm going to convert that to a double as well. So where was that text with the actual code? Here it is. Numerator needs to be the top one, and denominator needs to be the bottom one. All right, I will upload that. I wonder if it's that way in the screenshot. Yep, so I need to take a screenshot of my new version. Let's do that. Let's undo this change. There's our class. Screenshot time. I'll fix the PowerPoint later with a proper screenshot. I'll fix it later. All right. Okay, so now it should work because the constructor has been fixed. If you haven't fixed it, remember that numerator should come first, unless you're going to modify it the other way, right, and make it say fraction 2 over 1 is supposed to mean 1 over 2. And then cast one or both of the operands of the division operator to a double, and it should pass the test. Run all tests. Look at the Solution Explorer. Excuse me, Test Explorer. And it passed all one test, right? There's only one test. It's okay. I think we ought to add some other methods though, so that we could test those. Like what
Hey,
else
Jeremy.
might we want to add?
Jeremy, do you want to ask her if anybody needs a break?
Yeah, let's do that. Yeah, let's do that. We've been at this almost an hour and a half. Why don't we come back at 2:30 so you can take a biological break or whatever.
Mm-mm.
Yeah, if you can read that. I made some spelling errors, but in chat, I said the C# intro with unit test PowerPoint has been updated. I'll also post it right here. It's just got the fix to the code, to the constructor. Ooh, and that's a big file, so it's taken a while. 30 megabyte PowerPoint. Oh, I meant to pause the recording and I didn't. All righty, so I don't need to resume it. Okay. Has anybody been able to get this to work? Just curious if somebody was playing along and actually got it to work, because that would be cool. Sorry if you didn't, but try to get it to work over the evening. Follow the steps in the PowerPoint. So if we look at the tests that we created, excellent, Robert, thank you for trying it. So if we look at the tests that we created on Windows, it has this keyword test method here, test class. Now that's using MS test, using NUnit, which you saw on the Mac, looks a little bit different. That's okay. If you just modify the template that it gives you when it adds a unit test to it, right? So it's got the setup keyword, and we're not setting anything up, and it's got the test keyword, right? A little bit different, same idea, ought to be easy to follow. Cool, Rob, I'm glad to hear that. Glad it is working for some folks. Excellent. All right. Well, we're going to do some test-driven development, meaning we're going to write the test before we write the code. How about a multiply function? Multiply is really easy to implement, right? Because it just takes one fraction, multiplies the tops together, multiplies the bottoms, and then it simplifies it. So let's write a new test method, right? I'm just going to copy this one and paste it. Well, not quite, but I'm going to copy that little keyword there. You would do your own thing on the Mac. Public void multiply test, right? And so we need to create two fractions so that we can multiply one by the other. So fraction F1 is equal to new fraction. Fraction F2 is equal to new fraction 2/1, right? Because when we multiply them together, 1/2 of 2 is going to be 1. And so F1 dot multiply by F2, right? Now that method doesn't exist yet, but that's okay. We're going to go and add it. Once we have done that, we're going to get the value of F1. So forgive me for copying and pasting those 3 lines. Grab those 3, paste them, and 1/2 multiplied by 2/1 is 1. So that should be our target value. But we don't have a multiply yet, do we? The multiply method is going to what? It's going to take a fraction. Now, since I have this error right here, Visual Studio is kindly offering to create that method for me. Generate method fraction dot multiply. Why not? I'll fix it to what it actually needs to be in a minute, but I'm just curious at what it looks like if I run the method that it generated. Now it's going to crash. It's going to fail the test, but that's okay. We wouldn't expect it to actually write a working method, right? Because if it could write all of our code, we'd be out of a job, right? And so get values succeeded, but multiply test failed. Why? It says the method or operation is not implemented. That's because the multiply method threw its own exception. When I let Visual Studio add it, here's the code that it created, right? Multiply, throw, not implemented exception. Obviously, we don't want to throw a not implemented exception. So how do we implement multiply? What we do is we just multiply the top and the bottom together, right? So int top is equal to, and there's simpler ways, but I'm going to try to write this in a way that looks best to me. Numerator, this guy's numerator versus F2's dot numerator. Or why don't we call it other, right? So I'm going to rename that parameter to other. And the top of our new fraction is this numerator times the other numerator. And the bottom of this fraction is this dot denominator times the other's denominator. And so now this guy's numerator becomes the top. This guy's denominator becomes the bottom. And then we call simplify. And guess what? I did not write a simplify function. So that's not going to work yet. That is something for us to add. However, the value of it's still going to be over 1, right? I don't think this has a toString method either, so maybe we'll add a toString method to it. Maybe we'll add the GCF method, and maybe we will add the simplify method, or I could just post that code. All righty, so it still runs without crashing, but main doesn't call the multiply function. The only thing that calls the multiply function is the test code. So we're doing test-driven development. We wrote the test before we implemented the code. And that is a common programming paradigm. You can sit down, figure out a lot of the methods that you need to write for this, and then you write test code that's going to call all those methods, and then you go in and you implement them one by one. And once it passes all the tests, and you've gone a good way towards implementing your project. And I keep clicking run rather than test, run all tests. And then view the test explorer, and it passed. The multiply test passed. So even though it's not simplified, 2 over 2 still divides out to being 1. So it passed the exam. Why don't we go ahead and add a toString method? So I need to go back to my fraction class, public override toString. We're overriding the toString method that it gives us. It fluffed it out with a whole bunch of stuff automatically, so I deleted that. This is the end of the fraction class. I like to just put that as a little comment so I can keep track of my curly braces. All right, and so we're going to return the string curly brace numerator in curly brace slash curly brace denominator in curly brace, end quote, semicolon, right? That's what our string version is supposed to look like. But we'd better test it out, right? We need to write a test for that. So we're going to add to our fraction tests code another test of toString. It's going to look a lot like get value test. So I'm just going to copy and paste it, including the test method tag there, or the test tag on the Mac. So this one's going to be called toString test. What's it going to do? It's going to create a fraction, and then it's going to call toString, right? String result is equal to empty quote dot, or empty quote plus F1, right? Converted to a string, which invokes toString. If you don't like the way that looks, you could just say F1 dot toString and it'll work just as well, right? Guess that looks a little bit more precise, more conventional. So, and what's our target supposed to be? Our target is just supposed to be 1 divided by 2, right? Because that's what our fraction looks like. And then assert R equal target result, and it's not that get value failed, it's that toString failed. And by the way, I think I did not create the correct string down here on multiply test. I think in my copying and pasting, I left get value here when it should have been multiply failed. So those are the two new methods that I've added to my test function, to my test class, fraction test.cs. And there's my toString method and my multiply method. Let me put all of this in a text file for those who want to play. All right. If you need to open the text file to compare the methods that I added to yours, feel free. And maybe I should have waited until I added the simplify and stuff, but I don't know that we need to add the simplify and stuff. I don't know. Why don't we? Let's go ahead and do that. And then we're going to switch over to creating a graphical user interface, because we will have gotten the idea of unit testing enough to proceed. And I think it would be neat if you got to see the creation of a graphical user interface. Unfortunately, I have absolutely no idea if this will work on a Mac. I need to try it this evening. So the Mac users might just have to sit and watch and be interested, but I think it does, but we'll see. All right, so under program.cs, we need our two functions, right? Our GCF function, and we need our simplify function. And then several of these things need to call those. So underneath the constructor, I'm going to add the GCF function, public static int GCF. The only reason I made it static is so that I could call it outside the context of this class without using a class, without using an instance. On the other hand, we could have written it just so it only modified its own data, in which case we would not have made it static. So x is equal to math.min of the two parameters passed in, v1 and v2. Int y is equal to math.max, right, the larger of the two. And then we're going to start our factor off as 1 because everything has 1 as a common factor. And this will certainly only work for whole numbers, not fractional numbers, but we're only passing in ints anyways. And then for int value equals 2, value less than or equal to y, value plus plus. If x modulus that value is equal to 0, if it's evenly divisible by that value, and y is evenly divisible by that value, so y modulus value equals 0, then this is a valid factor. Factor, not favor, factor equals value. And then we return the value. Right? What? Return the factor. There we go. Oh, I forgot my equal sign up here where I said int factor 1 and factor equals 1. How's about that? That'll help.
Do we want to print that?
I don't think we need to print anything if we're calling GCF, but why don't we call it from our simplify function? Now this is not static because we're actually using the data that's in this class. So public void, it doesn't return anything, simplify. Public void simplify. So we need to get the factor. Int factor is equal to GCF, parentheses, this dot numerator, comma, this dot denominator. And then we need to divide our numerator and denominator by that factor, right? I mean, I guess we could check to make sure it's greater than 1 first, but it doesn't take long to do this math. Int, or this dot numerator divided by equal a factor, right?
You haven't really protected it from 0.
Yeah. Absolutely, this thing will crash if you pass in a 0 as a denominator. And how would we fix that? The constructor should eliminate any chance of creating a fraction with a denominator of 0. It should probably throw an exception if that's the case. At the very least, it should refuse to do that, maybe print an error message and default it to 1. But the appropriate programming thing to do would have it throw an exception instead, because that makes it a responsibility of the client code to check that, right? To appropriately check that. Okay, so this dot denominator divided by equals factor. And that's enough. We're not returning anything. And one could argue, and some people implemented it like this on one of the last seminars, that multiply should return a fraction and simplify should return a fraction while leaving the original data alone. But that's not how I implemented it here. Okay, so those are our our two new methods, simplify and GCF. I will update the text file and resend this with those, but we should test it as well.
Say, Jeffrey.
So I'm going to copy this, just a sec.
Okay.
Did I close it? Apparently I did. I see a question that I missed. I apologize for that. Let me send the file to you and then look at the question.
Does this automatically update the Canvas, the stuff that's in Canvas also?
Nope, I have to re-upload it, but we did not have this there yet, but we will. Okay, so is toString, very, very, very good question. We just created a toString method. There already was a toString method. And what this does is it effectively replaces it. If you need to get a hold of the original toString method, you can. Like if, I don't know, if we were going to add some method to our fraction class, I'm just going to call it test and then I'm going to delete it. Right, public void test. And we needed to call the original version of it, we would use the base keyword. Base.toString, right? And so we're calling the root classes toString method instead. Otherwise, if we just call toString, it's going to be calling the one that we wrote. Does that make sense? If we override it, it replaces it. It's no longer available for calling it. Well, it manages to intercept all the calls and to hook it up to the one that we provided the override for. All right, cool. All righty, so how's about we go to fraction tests and we could test the GCF function, right? And we could test the simplified function. Let's test the GCF function first. So I'm going to copy this test method tag or whatever it is on the Mac. I think it's just the word test. Public void GCF test. And we could create several different tests, right? We could test 1 over 1 to make sure it figures out that the greatest common factor is 1. Just like Charles was talking about, you want to avoid putting too many unit tests in the same test. So I'm going to make a GCF test 1 and a GCF test 2 and a GCF test 3 and so on. So double result, excuse me, it's an int, isn't it? Int result is equal to fraction. We don't have to create a new instance because it's a static method, fraction.gcf of 1 over 2. Or how about 2 over 4? We'll test it several different times. And the target of that is 2, right? And now we're going to assert that they are equal. So I'm just going to copy that assert statement and paste it and make it say GCF failed. But that's only one test. Let's add some more. About the only test that I'm not going to do is setting the denominator to 0, right? So I'm not going to test it with any values of 0. But how about we test it with 4 over 4? If we test it with 4 over 4, the greatest common factor is 4.
Oh.
Then we'll test it with prime numbers, and the greatest common factor is going to be 1. So this is GCF2. Whoops. And let's make a GCF3. So what's the greatest common factor between 3 and 7? There's no even divisor. I mean, there's nothing that's larger than 1. So we have our 3 test functions. To get them all on the screen, I have to zoom out just a little bit. There we go, right? And lastly, the simplify function. Now, I did not modify any of my code over in program.cs to actually call simplify. ToString should call simplify. Why not make multiply call simplify and the constructor call simplify? But let's add the test for it first, right? I forgot my tag, didn't I? I have test method here, but I forgot to put that tag in front of the others. A copy paste fail here. All righty, so those are the 3 test methods for GCF. And now we're gonna test simplify. This one's gonna look an awful lot like one of the others. So I'm just gonna copy one of these as a template and then make some changes to it. This is simplify test. It creates a fraction of 2/4. And then it calls simplify on it, f1.simplify. And then we're going to call ToString on it. Like that. But what's our target? Oh, forgot to change that to be a string. Our target is supposed to be 1/2 when it is appropriately simplified. That test is going to fail, right? Because we have not made ToString call simplify. The other should work, right? We're pretty sure that the GCF function worked. Simplify is not going to work because, excuse me, ToString is not going to work. Oh, I think it will work. I think it will work. Yeah, because we're explicitly calling simplify. So let's give it a whirl. Let's run it. Great, it works. Notice that we have never even touched main. We're doing all this development without having actually gone in and used this new code. But we're going to be pretty sure that this code works, and then you can hand the code off to somebody else and they'd be able to take on running with it. So run all tests, view the output, and indeed it did work.
Pretty fast too.
But we should modify the multiply test function. No, we shouldn't. But we need to go in and add the calls to simplify, right? Because if we printed out the fraction after we multiplied them, like if I just stole this code here and went into main and printed the fraction out, right, after we multiplied it, it would not be simplified. So I'm going to make a few more changes. The constructor is going to call simplify. Simplify. Right? I changed the constructor. I don't see why get value needs to call simplify. It'd be nice if multiply called it, in my opinion. Every time we change the values, I think we ought to simplify it. And I think that ToString ought to do it. Now, if we did a thorough enough job of checking the values as we changed them, we would not have to call it in ToString. And strictly speaking, ToString should not modify the values, should they? So maybe I'll just leave that alone, right? Maybe I won't make ToString modify it. That's kind of a hack, right? To try to fix things every time you print it out. Well, it should have been fixed to begin with. So I think that I'm going to make sure that I haven't broken my code by making those changes. Test run all tests. And yeah, it runs nice and fast. Test Explorer. Okay, so we have a lot of tests that are succeeding. I'm pretty happy about that. Let me update the text file one more time with this for those who are playing along, because I know it's hard to follow along with everything I type, especially when I'm blipping back and forth between files. All right, send that to y'all, and let's stick it in Canvas as well.
It goes in modules, right?
Yeah, let's go put it in modules.
There's lots of stuff in modules now too.
Yeah, we could break it up into source code and something like that, but I think it'll be clear enough. All right, so we want that stuck in Canvas as well. Yeah, let's go ahead and make a new module called source code. And we can move this to the source code module. And also we had a, where'd it go? Oh, code demonstrations from lecture, I already had it there. Fine, okay. So there we got all of them right. All right. What do I want to do next? I want to play with creating a graphical user interface. And I'm going to need to check something to make sure that I haven't made a mistake. So I'm going to run through this very quickly first without explaining what I'm doing. So I'm going to choose File. Well, why don't I close the solution? And then I'm going to make a new project, which is a desktop application rather than a console app. And then I'm going to choose that I want, do I want a WinForm app or do I want, yeah, let's give that a try. And I actually think that that's the wrong one. I think I want the WPF app, but I do not recall which one it is. And that's why I'm going to run through this quickly. All right, so what it's doing is it's creating a framework for a graphical user interface. And yeah, I'm pretty sure that this is not what I want. So I'm going to go and I'm going to choose the other one. Wrong.
Wow.
All right, so I'm going to call this Aero3 demo, right? It's a desktop app. It's a Windows Form app. I'm going to click next. Oh, see, could have been one of these two. Why didn't I take the notes from which one it was? Which one did I just test? Okay, I'll show you the problem that I get if I choose the wrong presentation layer format. When I go in and I try to create unit tests for it, it's going to complain about it. And so I'm sure that it's fixable, but I'd rather create the one that it works natively on. So hurry up. All right, so what is it? What are these graphical user? It comes with a form designer so that you can drag buttons and drag text fields and things like that right out onto the screen, right? So I put, not that you can see that, it's too tiny, right? So I just put a text box on there and I add a button to it. But all I'm going to do to make sure that I've got the right one going is I'm going to create a method called test, right? Or maybe make it an int, and then I'm going to tell it to create unit tests and see if it goes okay, right? And if I get an error message, then I know I chose the wrong framework. All right, so right click, create unit tests. If it complains bitterly, then I chose the wrong one. It actually worked, so that was the right one to do. No, Now we're getting these errors. Reference cannot be found. Let me try the other one, and I know that I can fix that by changing the settings like you have to do on the Mac and adding a reference. But if I can choose desktop here, and I can choose Windows Forms app, like that, Windows Forms app, and choose next, and choose create. That brings up the Forms Designer again. And I need the toolbox to play with so I can drag things out. I don't see my toolbox, so I'm going to do View, Toolbox. And I'm going to drag a button out, right?
Right.
And I'm going to double click on it. And when I double click on it, it creates the method that is invoked when the user clicks that button. So when the user clicks it, it's going to invoke this button one click. I could prove that. I believe there's a code snippet for message boxes. If I type MB tab, it expands it to messagebox.show. And I'm just going to change this to clicked, right? To prove that it's been clicked. But I'm also going to create that public int test method that all it does is return a number so that I can create a unit test and make sure that the framework hangs together. And if it doesn't, then we can go ahead and create the graphical user interface anyways. I don't want to get stuck on one thing when we could be covering it. So let's right click inside int test, choose create unit tests, see if it works successfully. And there's that error that I was, I need to update the PowerPoint to say if you get this error, then ignore it. Value does not follow. I need to Google up to see why I'm getting that. All right. So now I have a form designer. And I just have a sample little test function that, you know, if I come over here and I click on form tests, it created a test function, but all it does is fail. It auto fails. It calls assert.fail. Instead, I should call my method, my test method, which was over here in program.cs. Where'd we go? So int result equals program. That's not giving me any luck. Form 1, that's the name of my class. So come back to my test code, and I'm going to call form 1 dot, and it's not finding my test method. I thought I made my test method public. And like I said, if I can't get the test to work with this, I'm just going to ignore this part and go and work on creating the user interface. Well, there it is. Am I in the correct namespace? Do I need to add using namespace Windows App 11? Probably. So I'm going to come over back to the test using Windows Form App 11. Oh, see, it's already in the same namespace, so it should be taking care of it. All right, I'm not getting it. I don't want to keep wrestling with it, so I'm not going to worry about fixing the tests. It doesn't know that that's a public method. That's aggravating, and I don't want to get stuck on it. I know I've said that, but I really don't want to get stuck on it. Right? It's a public class. It's a public method. Okay, forget it. All right, so I'm gonna go from here. I'm gonna ignore the testing and not gonna have integrated testing, but that's okay because I just want you to see this, to experience it. If you're running on Windows, I need to check to see how much of this functionality we have on the Mac. All right, so why don't we make a text field, a text box, and another text box, right, that are going to contain two numbers. We need to tell the user that it's going to contain two numbers, right? So I'm going to drag two labels out. Now, can you see that? No, not really. I'm sorry about that. I can increase their font size via their properties. So I'm going to choose that label 1, right click and choose properties. And somewhere it says font, right? And I can increase its font size. Not 8 points, that's teeny tiny. How about 16 points?
16, well,
That's a nice big label, right?
14 would probably.
Now I made a mistake and I double clicked on that text label and it created a method for it, which I don't want, right? Because if you double click on a text label, it's not supposed to do anything. However, it's not hurting it. So for now, I'm leaving it alone. What I really wanted to do was to change the text, right? So I'm going to right click on it. And since there's no change text, unlike if you're using NetBeans or some other form designers, I'm going to click properties and I'm going to find where it says text, right there. And it's going to change it to say input 1. Now I'm going to repeat the process for the second label. What was the size that I made this one? I made this one have a size
16.
of, did you say 18?
16.
16, okay, I'm gonna do the same thing for this one. Double expand the font tree in the properties, change the size to 16. I'm gonna do that for the text boxes as well, right? They need to have the same size font. All right. And this one needs to say input 2. So I need to find where it says label 2 out here in its properties. And it's right there, teeny tiny print, sorry, and make it say input 2. Now, why not drag these text boxes right to the sides of it, right? And let's make a button called add so that if they type in, 1 and 2, then it adds them together.
And
So let's drag a button out and change its font size. Make it say add. So I need to find its text. I don't want it to say button 1 anymore. I am accidentally changing something down here I did not mean to change. So I hope by hitting escape, it got out of it. All right. Where's the text for that button?
oh, I think it's down.
Oh, it's no longer selected. All right. Here we go. And we're going to say add. But there's one more fairly important change, is that the name of the variable is just button 1, which means that when I double click on it, it says button 1 clicked. Well, that's okay, but that's kind of generic, right? So I'm going to go back to the designer. I'm going to remove that method that I just made. How do I do that? See this lightning bolt here? This says events. I've been modifying the properties. Now I'm going to change events. And we see this top word here is click. When it's clicked, it calls button 1 click. I'm just going to wipe that out because I'm going to recreate it in a minute. So now that should be gone from my CS code. If I go and look, see, I also need to do the same thing to label 1 because I accidentally added a handler, click handler for label 1. So I'm going to choose input 1's label, the label for it. I'm going to find its click handler and delete that as well, because it's not supposed to do anything when we click on that. I need to give this a good variable name. It's not a good variable name yet, so I'm going to go to properties and find its name.
Plus, click, add, click, and
Here he is. No, that's the text. It's just called button 1. Here he is. Okay, there's two different sortings. There's alphabetical sort and then there's categorized. I'm choosing alphabetical sort, that second one. And up at the top of that one, sorted by alphabet, well, parentheses come before anything else in the alphabet. There's the name of our control. And so I'm going to call it the add button. And forgive me for liking underscores. I know it's old school. Here we go. I'm going to hit enter. And then I'm going to double click on it. And it's going to create a method called add button clicked. Originally, all it's going to do is print a message. So I type in MB tab tab, MB tab tab, and I'm going to make it say add button clicked. Right? So how are we going to make this work anyways? Am I going to put a third field here so that when you add two things and you click add, it fills in the third? Or am I going to make it so that if you click add, it modifies the first value by the second one? I think that'd be kind of cool, but for the purposes of this demonstration, it might be clearer if we had a result field instead.
could you
What else
move
do we
that up
want?
right below 1 and 2?
Yeah. What else do we want? Well, we want these things to be pre-filled with the word 0, with the number 0, so that they know what to type. So let's go do that. And then we'll also add the result field underneath it. So by clicking on the designer, I need to click on this and figure out where its original text is. That text, that field right there, that input field doesn't have any text. Well, it sure does now. I'm putting a 0 there. Same for this one. I'm going to click on it, find the text property. It's easy to find when it's sorted alphabetically. Put a 0 there. All right.
You have one more field?
Yeah, let's add, I'm going to copy and paste these guys. Copy those two. See, I just shift clicked it. I selected one. I shift clicked to add the other one. And then I right clicked and chose copy. And then I'm going to right click and do paste. And this is going to be our result, right? And again, I double clicked on the label to edit the text because I'm used to using an editor that does that. That was my mistake. Doesn't matter, but I need to select it and change the text of it to say result. That's a good enough default value, but the variable names, I think I might want to change a little bit. Let's check to see what their variable names are. This one is called, that top one I just clicked on is called text box 1. I think I'm going to call it text underscore input 1, right? The second one, I'm going to call it text underscore input 2.
Could you
And this
actually
one is
call
going to be called text underscore result. To me,
Well,
that makes sense.
Well,
Pardon
that
me?
text, hey, do we have to convert the text to a number?
Exactly, because it's going to come in as a string. So we're going to have to convert it to a number in order to do the math, and then we're going to have to convert it back to a string.
Is there some way that we could actually start it so that it goes in as a number?
Unfortunately, no. Just like when you type in input from the console, it's always a string and we have to convert it. All of the fields on this thing come in as text and we have to convert it. But it's not too hard to do that.
You've got a number keypad.
Yeah.
Or you've got the numbers up at the top.
I mean, we could put a little, you know, keypad right here where they have to click 1, 2, and 3 and so on. But let's go and make our add button read these values. We've given them good variable names and all that. So, oh, I still need to at some point get rid of that label 3 click handler. But when the add button is clicked, let's do string S1 for input 1, S2 for input 2, and R for result, or SR for result. And let's get the string from the control. S1 is equal to, and what's the name of the control? I don't remember, so I'm going to type this dot and find the name of my text field, right? Text input 1 dot text, T-E-X-T. Please give me the text of that field so I can do something with it. Same thing for S2. S2 is equal to this dot text underscore input 1 dot T-E-X-T.
Wouldn't it be input 2?
It sure would be. Thank you for correcting that. There we go. And now we need to convert them to doubles. And here's where I should use a safe version of conversion called try parse. And I'm going to go ahead and demonstrate it because otherwise we just have to handle it at exception handling, right? We have to catch any errors that conversion can throw. I'll show you what I mean. What if I run it right now and I type in some garbage, right?
ABC.
What if I type in this and I click add?
Oh, okay.
It says add button click, but then it blows up. Oh, no, it doesn't because I didn't call the conversion function yet, right? So if I was going to create two values, right? Double D1, comma, D2, comma, DR for result. And I say D1 equals double dot parse, parentheses S1. That's what's going to crash, that line right there. Because if you pass in garbage, just like Charles said, garbage in, garbage out. So if I type in some garbage here and I click add, it's going to break my code. Boom, right? Throws an exception. And I can figure out what exception is being thrown and add a try catch handler for it, right? But all instead I'm going to do is use a different version of parse. It's a little bit more complicated to use, but it's okay. Bool okay. Okay is equal to double dot try parse. And the string we're parsing is S1, and the result needs to be stored in D1. Notice the use of this out keyword. We already talked about that. Now, I don't know why it's underlining it so emphatically. I'm hoping that goes away when we rebuild it. It did, okay? So let's make this maybe say bool OK1, comma, and OK2, so we have two Boolean variables to play with. What does try parse do? It parses that string, stores the result in that out variable, but if it fails, it returns a false. If it succeeds, it returns a true. So it's got two return values, right? So one of them is actually being set by the return statement, and the other one is being set back in the reference variable. So OK2 is equal to double dot try parse S2, comma, out D2. Try parse is a safe version because it doesn't crash if it can't change it. It instead just returns a false. And we can check, right? Whoopsie, where did that come from? If not OK1 or not OK2, right? If either one of them is false, then we're going to pop up a message box that says error. Or maybe we'll just set that resulting field to error, right?
Right.
SR is equal to invalid input, right? It'd be nice if we told them which one was wrong, but I don't want to take the time to figure out how to do that. But if they were okay, we can add them together, right? If they are okay, then DR is equal to D1 plus D2. And the result we need to create, right? SR is equal to dr.toString, right?
ToString.
And then we need to set the value of that result field. Remember, we created a result field here and we called it text underscore result, we're going to say this dot text underscore result dot text equals that string that we just built, the resulting string. Because when we get our input, it comes in as a string. When we want to display it as output, we have to convert it back to a string. Now, we probably would want to make this a little bit more elegant than what we have now, because we would have a lot of code we would need to copy and paste if we were going to do a subtraction and a multiplication and a division. But I'm happy enough leaving it as is. We know that the add button is being clicked, so I'm going to get rid of that message box, right? We don't want to see that anymore. So here's my button handler. When it's clicked, we get the input text for those input fields. We try to parse them into our doubles D1 and D2. If they're not okay, we set an output message that says invalid input. Otherwise, we actually do the math, and then we set our output message to the result of that math. Then we set the text of that field.
Boy, this is almost at the assembly level.
It's a little bit detailed, but that's okay. The result is worth it, right? So 56 and 56.
The add's still there.
Yeah, 56 and 56 added together is 112. But if we type in garbage, then it says invalid input. Maybe we could just make it the word invalid, right? And if we were awesome, we'd make it so that it would check that one as soon as it was changed, and it would make sure that it was a number, and it wouldn't allow any letters. And how would we do that? I'm just going to show you how, and I'm not going to actually do it. In the form, I would click on the field, and I would check the events, and I would find one that looked good. Like whenever the text was changed, please call this handler and make sure it's valid, right? But I'm not going to do that. I'm not going to actually make it change. Another thing we might want to do is, if I have 1 plus 2 and I click add, and then I change that to 30, then I call you up with a screenshot and I say, your code is garbage. I clicked added 1 and 2 and it said 30. No, you typed in that 30, but we need to make it so that this is a read-only label, right? This is a read-only field. So I should be able to go back into properties and find a place where we can make it read-only. Enabled is true. Yes, we want
After
that.
password character.
Oh, password character is cool.
No, well,
It just displays dots, right?
Yeah. Yeah, read only was down underneath password
Oh,
only.
did you see it? Okay, good,
Yeah.
good. All right. So he is true now. Read only is true. And it kind of grayed it out. I'm not going to fix that. I'm sure we could change that by finding, yeah, the background color. But it's okay for it to be gray, right? It tells the user that they shouldn't try to type it. So 1 plus 2, 5 plus 6 added is 11, but we're not allowed to change it. Okay, so there's our app. Yeah,
Could
password text is cool.
For hex and binary and the rest of it too?
Yeah, we could make it handle multiple forms of input, or we could put a conversion button that would show what the output in those various forms. That'd be cool. I'm just going to show them what text box with password set does.
Yeah,
so here's our text box, and I'm going to make it say password character, maybe asterisk, right? And then when it runs and they type in anything, it gets replaced with an asterisk. That's kind of cool. Let's get rid of that. Now for the final cleanup, if I go and look at the CS once more, as I recall, there was this bad method. I don't recall if I can get rid of it just by deleting it like that, if that's going to generate an error or not. There were build errors, right? So I should not have deleted the method in the code. So I'm going to undo that deletion, and I'm going to change it the correct way, which is by going to the form designer, clicking on the field. Which one was it? Input 1? Let's look. Oh, label 3, click. Okay, that's that one.
Result. I thought,
And then finding its event handler over here and saying, nah, we don't need an event handler. So I'm going to delete that field. All righty. And we can play with this stuff for a long time. And actually, we went faster today than we did on the prior seminars. And so we're getting here a little early, but I don't want to get pedantic and just keep making little changes to this. But what would make this a better app? One thing that'd make it a better app is if after you type a number in, it repositioned the cursor there, right? So that you could type in another number, right? That'd make it nice. So if we can figure out how to do that, and with 1 minute Googling, then let's do that. Set focus on text box C#. Because what cursor, where the cursor is called the focus when you're doing graphical user interface design. Maybe it's just, maybe there's a set focus method. Let's find out. Let's go in here, and when they press the add button, I'm just going to double click to go back to it. Whoops, no, that's the actual program running in the form designer. It'd be cool if we spotted which one had the problem, so we set the focus there. But for now, let's just try to set this dot text input one dot focus. Hopefully that'll bring the cursor back to that one when we click the add button. Right? So if I type 56 and 67 and I click add, now the cursor is back there. What if I wanted to set the whole thing highlighted though, so that they didn't have to set, you know, backspace over it? Well,
could you clear it at the same time?
yeah, we could clear it, but I think I like the idea of leaving it. Text box set selected C#. Select the text in a text box control. Let's go and take a look. Set the selection start property to the beginning. It's an index number. And then set the selection length to the length of the text. Well, that doesn't sound hard. So we have two things. We have a selection start and a selection length. Let's go try those out. After we set our focus, this dot text underscore input one dot select, select all. Okay, that makes it even easier, doesn't it? Isn't that sweet of them? All right, so type in 56, 67 and click add, and now it's sitting there ready for me to type in a new number. My users are going to be happier. Another fun thing might be,
if you set it up so that you hit the enter key and it goes down to 67.
right. I wish it did. We could probably figure out how to do that as well. We would have to add an event handler for this control, and we would have to check to see if the character that was hit, the text change, was the enter key being pressed. That's a little bit beyond what I know how to do in 2 minutes. So I'm going to leave that alone.
Okay.
But I think I would like for it to highlight the errored text, right? I think I would like for it, if we detect an error. So how are we going to do that? We're going to check only one of them at a time, right? If it's invalid input, we need to figure out which one, right? If OK1 is not valid, then we need to select input 1. Or, or if,
do you really need an or?
Well, I want an
After
or.
that if, you could just, if it fails that if, then it's automatically got to be okay too.
You're right, but I don't want it to be selecting two different text fields. I mean, I guess so. Yeah, let's do what you're suggesting because we can change the text color to red for the invalid ones. Right? So this
Right.
dot text input to set focus. And so really this is only going to be setting, I think I would change the order of these so that it'll put the cursor on the top one that's failing. So we check OK2, and if it's got a problem, we set its focus. But if OK1 has a problem, then that means input text field 1 has a problem. So we set our focus there instead. And let's see if we can set our text color. This dot text underscore input to dot, that didn't work because I typed lowercase. Text input to dot color. For color. Equals color colon red, or is it colon dot red? Yeah, like that. Now it's poor form to use colors to indicate what's wrong because what if you're colorblind? But this is just showing, right?
Yeah. You don't.
And same business here. If it's got a problem, we want to highlight that one in red text as well, right? So text input 1.4 color becomes red. But if those things were okay, we don't want to set them to red. We want to set them to black, right? So I think I'm going to rewrite this a little bit, move these out of here so that these checks happen above this joint if OK1 and OK2, right? So if it's not okay, bad news. Else, just set this dot text input 2 dot for color back to color dot black. Same business here. Let's check to see OK1. So I'm moving that above this check as well. And the reason I'm breaking it out there is because I don't know, it just feels better to me because we have to execute this code that changes it to black. We have to execute the else, or else once it turns red, it's going to stay red, and we don't want it to do that. So else text input 1.for color equals color dot black, right? And so what are we doing here? If problem, flag this input as error.
That if not OK1 and not OK2, isn't that somewhat redundant?
No, because one of them could be broken and the other one might not,
And the
right?
other not.
Yeah, we could type in garbage in the field OK2, but leave OK1 good. And if you're saying, is this redundant? Yeah, we could consider it redundant. We might just want to move this message right here. But then our else is going to look odd. But maybe we do that. Maybe we put this message here, invalid input here, or just the word invalid. That'd probably do the trick. We also put that there. We are going to have a little bit of duplication there, but I think that's okay. And instead of doing this as an if else, why don't we say if OK1 and OK2, right? If both things are fine, do that. Ooh, and I have build errors. Managed to break the code. Oh, because I don't have string declared.
Yeah.
I thought I did. Okay, I better set SR equal to something okay, right? I better initialize it to a valid value.
0.
It's a string, so I'm just, yeah, we could do that. All right, let's give it a shot. All right, firstly, let's make sure we didn't break it. Now let's try it with some bad data here.
It was interesting how that happened.
Now let's type some bad data here. Wait, that's not bad, right? That one turned back to black because it's okay. And that one is left as red as being invalid. We change that one back and it's okay. All right, so then the question becomes, and I'm not going to solve this. I mean, I guess we have 20 minutes left, but I'm not going to solve this. I think what I'll do is for the last 20 minutes is we can ask, you know, if there are any questions, and then we can show what I want you to be working on overnight, which is just to finish off our fraction class. And then what's the last thing? Oh yeah, and then if we had any time, we can pick back up in the PowerPoint where we were.
What was the assignment 1 and assignment 2, or we still have assignment 1 and 2?
Yeah.
Fraction was assignment 2, wasn't it? And C# was unit test project.
I think they were vice versa. Well, we'll take a look. All right, I don't know why I'm staring at this. I lost my train of thought. These tests are invalid, so I just need to delete that entire shebang. Was there any other changes I wanted to make to this? And I think the answer is no. Oh, I was going to explain what I think the big problem in this code is right now. If I wanted to add a subtract, I would copy and paste all this code into it. And that's lousy, right? Because the only code that would change would be that line. And then if I wanted to create another one, you know, divide or multiply, again, I would copy and paste and change only that line. So what I would need to do is to come up with a method of shortening this, maybe sticking all of this stuff in a function, and then have like a preamble function that does all of this stuff and then sets this up. So I'm not going to work on fixing that, but we would want to do that. All right, let's go and take a look at our assignments. Where is Canvas anyways? All right, we have assignment 0, files from prior courses, assignment 1 and assignment 2.
Assignment 1, unit test project.
Oh, and in completing the fraction class is assignment 2. All right, so here's assignment 1. Download the zip file, expand, extract it, and open it with Visual Studio. And it's called Crate Calculator. And I'm just going to let you follow the instructions. I could open them up. Yeah, let's look at one of the Word docs. But I really don't want you to work on both of these overnight unless you just really, really want to. You know, you can wait until tomorrow to work on these. If you do get them finished, please come in anyways, right? So yeah, you have to have attendance tomorrow. So please come in anyways, even if you're just going to be here for a couple minutes to, you know, prove that you were here. All right.
But what's the due date on these, Jeffrey?
Why don't we set them for tomorrow at midnight? Okay, so unit test project, here's the way the program is supposed to work, right? CBI crate builder, please enter all dimensions in feet, 1.5, 2, and 3. And it is supposed to print out a purchase form that says the dimensions, says the crate volume, says what the customer is charged, what our costs are, and how much profit we made. But here's what it does so far. Please enter all dimensions in feet. Enter width 10, and then oops. Well, that programmer quit before he finished the job, right? Finish me. And then so it doesn't do very much at all. It only prints out a crate volume of 0, and it doesn't do anything else about, you know, charges and profits and stuff like that. So then there's a series of tasks to do, right? So crate has a height, width, and depth, and this explains. We're going to implement several different methods, a get volume method, a get charge method, a get profit method, and so on. And so you're going to modify the source code, which I include here if you don't want to unzip that package and open it that way, right? And you're going to make the requested changes. right? The document explains the changes and it tells you what methods you're going to add.
Yeah, Canvas won't unzip that for you, by the way.
Right, you have to download it first. Yep. And so sample unit tests, to get you started, create your test framework and then make your test unit look like this, right? So you're going to add some test methods. You want to get the volume. That's the first one you're going to test, but then you're going to want to test the rest of them as well, right? That's the Mac version of the test function. Here's the Windows version of the test function. I'm not sure why the Windows is nice and colorized, but the Mac isn't. But anyways, so you're just going to add the test framework and you go back to the PowerPoint to remind yourself how to do that. It's done automatically on Windows. You just right click and do add unit tests. On Mac, if you recall, it was a little bit more complicated. So you're going to do the changes of implementing the methods, get volume and get profit and get charge and get cost, right? But those are pretty simple formulas and they're given to you. So if you have any experience in using an editor and working with, C++ or Java or Python, you ought to be able to do those parts pretty quickly. Then the unit testing you may get stuck on, and that's okay. So you'll come in tomorrow and work on that if that's the case. So that's homework 1. Use the PowerPoint to remind yourself how to create unit tests, how to get the framework going and how to add unit tests. And once you do have unit tests, you're going to not only want to test get volume, you're going to want to test the rest of them, right? Hopefully I mentioned that. Oh, by the way, we didn't show this, but there are things called properties, which is when you add a variable to a class inside C#, but you want it to act like a function with a getter and a setter. And you do that so that you could modify the behavior of the getter and the setter. Like if on your fraction class, if you don't want anybody to set the denominator to 0, you could give it a set function that would forbid it or generate an exception or something like that if the denominator was set to 0. Okay, yeah, so here's the rest of it. Implement the get volume function, run the program to make sure it works, and add a unit test for get volume. And then correctly implement get cost, get charge, and get profit, and add unit tests for those. And then that's doing test-driven development because it's not going to have even be displaying the stuff until you do the last task, which is to finish the display output method. Once you've done that, you're pretty much finished. However, as a programmer, you love to keep improving things, so there's 2 more things to try. Go to the main method and tackle task 3, which requires adding a parameterized constructor. If you don't know how to do that, if you don't remember, we did an example of that in the fraction class. If you're still stuck on the idea, then ask about it tomorrow. Once that is done, modify the get volume test to use that new constructor. Okay, so let's go and look at the other one, and we will set the due date for both of those. I mean, really, as far as I'm concerned, if you have to work on it over the weekend to get it to work, that's okay, right? Nothing wrong with that. But it'd really be nice if we got it done Friday, right? Because you got stuff to do on the weekend.
Is assignment 2, Jeffrey, not worth any points?
Oh, it should be. Let's go see why it's not. Oh, you're right. It's worth nothing. No, it's not. We're going to give credit. All right.
Yeah, there we go.
Yeah, it's a little bit better. Let's set a due date for that one as well. And let's look at the notes for this one. Create a Visual Studio project. Use the source code in the attached file, which contains a fraction class. The fraction class ought to look remarkably like what we just did. And as a matter of fact, if you wanted to use your own fraction code, if you happen to have written any today, you could probably do that. When you're done, create a document that has a screenshot of your code running, the source code for your application, and a source code for the unit tests. Expand it as requested in the source code and add unit tests as well. So let's go look at the specific instructions. Well, they seem to be embedded in the TXT file. So let's go and look at the TXT file. All right, so this looks pretty familiar. It's got a GCF function. It's got a numerator and a denominator actually fixed. It's got a simplify function. It's got a toString function, and it's got a multiply function. So it's exactly what our current code is, right? I don't think there's anything in it that isn't what we were working on. And then, so here's our test functions, right? We're going to test just simply the creation of a fraction, and as long as that doesn't throw an exception, we're good. So I can't even think of an assert, right? Maybe there's just assert not true or something like that. But we're just going to leave that one alone, and that's all that the fraction test needs to do, is just launch it and make sure it works. But then we're going to have the GCF test, and the greatest common factor between 6 and 3 is 3. You can add more, just like I demonstrated today, right? A simplify test, where we simplify it. Notice that they're not using toString to test to see whether it got simplified. Instead, we're getting the numerator and the denominator values back out after we test it to make sure that the numerator is 2 and the denominator is 1. A test method for get value. A test method for get value test 0, which is when you try to get the value of 0 over 0. This one is just flat out going to fail. You get to decide what you want to do about that. You could decide that 0 divided by 0 is equal to 0, right? And so you could put an if statement in there, and if the denominator is 0. But it's okay to leave this test failing, right? Because that's a fact of life, right? Is that in the middle of development of a project, some things are not going to be working. And maybe we're pretty sure that the user is never going to type in 0 as their denominator, but eventually we want to get to it. And then toString. So those are the strings. And then there's something I'm going to demonstrate tomorrow called fake input. What is faking input? Well, if you were going to write an application that asks for the height and width of a rectangle, how would you test that in unit testing, right? How do you test the main application? Well, what you have to do is you have to provide mock input or fake input, right? So that when it's running in a test environment, you can say, okay, the user would be typing in a 7 here, and the user would be typing in an 8 here. And so that's what this does, but you don't have to work on this. You don't have to work on that. Okay. So what is left to do for this? Assignment. Add addition, subtraction, and division methods to the fraction class. Now, you may have to go back and do a little bit of research about how to do fraction adding and fraction subtraction, right? Takes a little bit of figuring out how to do it. And I would just do it in the simplest fashion possible. And if you get stuck tonight, I'll tell you what those simplest fashion possible tomorrow, right? Division's pretty easy because it's just like multiplication, except instead of rather than, where's multiplication?
Yeah, well, you just invert it.
Right, you invert it. So this dot numerator times the other's denominator, right? And this dot denominator times the other's numerator. So divide is almost trivial to implement, right? Copy, paste, change it to divide, and make this one, this dot numerator is equal to other dot denominator, right? And then the right switch, because that's how you calculate the division of a fraction, is you just invert the second one and then perform a multiplication.
You'll still call reduce, right? Or simplify?
Yeah, we'll definitely call reduce. I should have called it reduce rather than simplify. That would have been a better name. All right. I hope that makes sense. I would be willing to accept texts about this, but not a lot of them, because that's what the 3 hours tomorrow is for, right? So mostly, if you're going to contact me tonight, it would be about just getting Visual Studio up and running and stuff like that, right? Not over the specific assignments. So hopefully everybody's going to be able to have Visual Studio. Please do install it. One of the Mac users last time was unable to get the testing framework to work no matter what she did. And she was a Mac god and able to do things that I wasn't able to do, and still wasn't able to get it to work. So we suggested an alternate project, which was just to set up a test function, right? Rather than setting up the unit test that way, and so her test function would perform the unit test rather than being done in an automated fashion. But we really would like for you to be able to write it in the proper fashion. All righty. Well, we have 5 minutes left. I think that we don't need to try to struggle to fill up those last 5 minutes. So we all good? Everybody think that they're got a grip on it? Okie doke.
Okay. Yep, thanks. All right.
All righty, gang.
Yep. I'm going to go over to the tutoring center, Jeffrey.
Sure. I appreciate that y'all have been interactive and asking questions and knowing things that I didn't when I got stuck. So appreciate it. So yeah, see y'all tomorrow.